Okay, hi everyone, good morning. Thank you all for coming to this session. My name is Alina, and here's my colleague Fabio.
Hello everyone, good morning.
I hope you had a great first day of Debugging, and we are here to talk with you about everything there is to know about GraalVM and native image. So let's go. I'm thinking, do we need to share any organizational details? Or
Yeah, we want to make this as interactive as possible, so we encourage you to feel free to interrupt us and ask questions. Maybe raise your hand so we can see you. And we have set up this Slido thing. I'm not sure. It's not showing it.
Oh, what happened to our? Okay, technical difficulties. We can all relate.
We'll figure it out.
Yep. Did I kick it underneath unintentionally?
Got disconnected.
No problem. We can maybe keep.
Now it's good.
Oh my God, we kicked it. Okay. We are so sorry. We will try to steer clear of the thing. Cool.
Yeah, maybe we show this one more time.
Yes. This is our beautiful, intro slide. And what we were talking about, though, is that you can shout questions from the room. We encourage that. But also, if you are not so comfortable shouting from the room, we have this little thing, and we will show it later when we get to the, demos and stuff. So you can ask us questions there, writing down, and we will try to answer them. Okay, let's talk about GraalVM. So GraalVM is a high-performance JDK, so you can run your applications on it as you would run on any other normal JDK, but there is one more additional component on top of the JDK part, and that is native image, and that is this ahead-of-time compilation capability where you can produce native executables of your Java applications that no longer require JVM to run. And we will talk about that a lot in this session today. One more thing we want to share, because we are very proud of that, is that it's also an open source project. It's, as people tell me, one of the biggest open source Java projects out there, because it's indeed huge. And if you want to see how it's being developed, maybe contribute, or just see what's underneath, our source code is on GitHub. You can see our team. I think Fabio is also somewhere there. And yeah, we are very proud to be working on such a cool open source project.
Right. And I'm also part of the development team working on the developer experience, so everything that has to do with user developer facing stuff. So feel free to ask questions. Alina is our developer advocate. And so before we start, maybe a quick show of hands. Who has used GraalVM already? Okay.
Everyone in the room. Oh my God,
quite
this
a
is
few
our
people.
crowd.
So who of those are using GraalVM in production? Okay, couple. Very good.
Half-ish.
Yes.
So yeah, about the developer experience. So every time you face some, issue or bug or unexpected behavior in GraalVM, Fabio is your guy. He would be super interested to talk about it. So anytime you have an issue or something doesn't work as expected, Fabio will be very curious to find out about it.
Right.
Okay, let's see. Okay, we kind of started from that in the beginning, but just to get those things cleared out, because GraalVM is huge and can be a bit confusing what each part does, right? So as I said, it's a high-performance JDK and a compiler. So underneath, you have your normal OpenJDK/Oracle JDK. And the only thing that is different is that we have our own highly optimizing GraalVM compiler itself written in Java. So you can execute your Java programs on GraalVM as you would on any other JDK.
Yeah, and I think this is actually the core component of GraalVM, and it's the most innovative thing. I think because we can make Java faster by writing Java code, right? So the whole compiler is written in Java, and we can use it. It's very versatile. We can use it in different modes. We can use it as a just-in-time compiler on the OpenJDK or Hotspot. And you can also use this in the native image setup, so in the AOT setup. So instead of running just-in-time as a just-in-time compiler, we can ahead of time compile your applications and turn them into self-contained executables. And that's what we're going to talk about today primarily. And then the third category are our language runtimes. So we support language runtimes for many other languages like Python, Ruby, JavaScript, and you can use those to extend Java applications and embed other languages. And they can also do, you can use them as standalone drop-in replacement for Python interpreters or Ruby interpreter. And of course, you can also do polyglot programming, which you may have seen in the past, but we're not going to focus on this today too much. We'll be primarily focusing on the AOT bits.
Yep. And what is cool about those language runtimes, so as Fabio said, you can use all those languages together, right? But also GraalVM, it's cool how the project and its component are kind of enhancing and multiplying each other. So our compiler will also take care of your language runtimes, such as JavaScript, Python, etc., being very fast. And also, if you always had a dream of implementing a language yourself, Truffle, so our language implementation framework, probably will be the easiest way to do it because it will give you, well, the framework, but also all the tooling and the performance optimizations to have a very fast language. So if you always had a dream to have your own language implementation, Truffle and GraalVM would be a way to go. But with that, let's focus on this middle native image part of GraalVM. Okay, so this is basically what we talked about, right? So with GraalVM, you really get a choice. We just want to emphasize this once again because native image is so exciting that often people associate GraalVM only with native image. But if you want, you can also run GraalVM as your JDK and run your Java programs on GraalVM. And we have some users and customers who are using GraalVM as a JDK because for them performance is critical and they see better performance with GraalVM JIT as they would see with C2. But today we will focus on this ahead of time native image part of GraalVM.
Right, so the way native image works is it's more than just AOT compilation. So we run this static analysis, and as an input, we take your application code, your dependencies, the JDK, and something that we call substrate VM. So eventually in this executable, you still need a garbage collector and other runtime components. And these are provided by substrate VM. So this is the one that ends up in your image, if you will. And then we run this points, we call this a points to analysis. So we start looking at the entry points of your application. Then we trace through the code and try to find reachable methods and classes and types and whatnot. Then we can also initialize some of these up front. And then we take a heap snapshot. So we can, and this is where like native images is more than just AOT because we're not just compiling code, we are also taking a heap snapshot. So in that executable in the end that we get, you end up with a data section that has the heap written down and a heap snapshot, and all the reachable code is compiled into the executable as well. And of course, now you may be wondering, like, once we ran some initializers, maybe more stuff becomes reachable, and then we have to do another iteration of the analysis until we reach a fixed point, and then we know exactly what's necessary what's necessary to end up in the image, and everything else we don't put in the executable. So the executables are really small, and because we can initialize a lot upfront, they will start up very fast.
Yeah, I think it's very cool what Fabio said, that native image is way more than ahead of time compilation, because people often associate native image with ahead of time compilation because indeed it's very different from JIT. So, that's something that immediately catches your attention. But this heap snapshotting is equally important, right? Because it prepares your application, and then when you start it, you start with a snapshotted prepared heap, so it starts much faster, doesn't waste time and resources allocating those objects, but also eliminating all those unnecessary code. That's also very cool because you bring to runtime only the things you need, right? And then the things you never use, but you just have them in your JDK and your dependencies, all of that is eliminated. And that is how you get those super slim, super efficient, little native executables.
Right. Any questions so far?
Okay, but also we should maybe open, let me see if I can open on my phone this questionnaire thing that we have online. Yeah, we'll check it in a second. Right. But also maybe you want to ask something right away.
No.
Oh, okay. All clear now. Cool.
So don't worry, we don't do slides for 3 hours. We'll be
Yes.
switching to demos very soon. We quickly want to run you through what we think is necessary to understand native image, and then we try to show you some cool demos. Maybe some of them break, maybe some of them don't. We'll see. So yeah, we already mentioned fast startup. So GraalVM native image can help you deploy Java applications with a very fast startup. Usually the JVM takes some time to start up because you need to initialize the whole JDK up front, right? And if you're doing this on a computer, then yeah, maybe it's a Mac, and then the JDK needs to be initialized specifically for that Mac, and that happens every time you launch an application, which is fine, and it's cool that Java is portable, but at the same time, this is really bad if you want to do something like a cloud function, and what's really dominating is the JDK initialization, for example, in the beginning. And with native image, we can do all of this up front and essentially run with a pre-initialized heap. And then, very little needs to happen to actually start up that application. And now all of a sudden, your cloud functions, they start up really, really fast. So if you want to compare this, like JIT versus native execution, like in JIT mode, the JVM would start loading jars from your disk, then it would uncompress class files, right, and verify class definitions. So all of this is gray because we haven't actually done anything, like we're not running your application, right? So then finally, you get to the point where the application is running. It's running in the interpreter, which is like 20x slower, and then the just-in-time compiler starts profiling, starts to collect profiling information. So then eventually it can use that information to compile your code to machine code, and then you finally have reached peak performance, right? And with a native executable, we can do all of this up front, and then what this looks like is you just load the executable, and boom, you run at peak performance, right? And of course, now you may think, okay, but you're running the static analysis, and how are you going to get the same kind of profiling information to be on par in terms of performance? And lots of people are like, oh, maybe AOT is slower than JIT. But with this release, with the 21 release of GraalVM, or the JDK GraalVM for JDK 21, we finally reached the point where we can find, or native can finally beat JIT performance. And why? Because, well, we can also feedback profiling information back into the compilation step. And then you get the combination of both worlds. You get the JIT advantages and you get the AOT advantages, and so the analysis and the other things, that optimizations that we can do only because we have this closed world assumption through the analysis. And we'll try to demo this in just a bit to show you that we can actually reproduce this, and not just, and you can go and reproduce it yourself. Oh,
thanks.
Yes?
Yes, I just wanted to emphasize this here, right? So as you can see, there are way fewer steps to execute your program if you're running on native, because even as you were clicking through the steps of JIT execution, it already gets exhausting. You can see how many more steps are there. So this will be important when we'll be showing the differences between native and JIT in the demo. And one more thing I want to point out here is you can see, the way JIT executes your code is it starts with interpreted, because that's faster to get to the actual code execution, but it's much, much slower. And here you can say that, hey, but as my methods warm up, it becomes irrelevant because they will be compiled. There is no interpreted anymore. But it could be the case that many of methods in your app never reach that compilation threshold, and they will always be executed in interpreted. And even if those are fewer, smaller methods, it builds up, and then in native image, everything is compiled. So everything is compiled and efficient, and we will see how it works in a second. Okay, but some people might argue, okay, startup is great, but maybe I have a long-running application that doesn't start that often, and I don't care about startup that much. And I can agree with you that there could be other metrics and other goals for your application other than startup. So when it comes to memory usage, the situation looks very similar to when we were comparing the startup times, because if you're executing your code on JIT, you need to keep memory around for all that code execution infrastructure and metadata. you are executing your code dynamically. It gives you a lot of advantages, more specifically around peak performance, but it also means that you need to keep around memory for all those things that you can see here on the chart. While on native image, again, it's all precompiled and optimized ahead of time, so you need way less memory. And here we are kind of looking at, let's say, one application instance, but if you were to scale this for JIT execution for the JVM, you would need to add gradually more memory for the actual code execution infrastructure, while on native image, if you were to scale this, you would only need to scale memory needed for the actual application payload.
Okay, and then the next thing, maybe you want to do this?
Yep, let's do it.
Okay.
Okay, this is also a very cool thing, and I feel like this is not talked about enough. So there are interesting advantages to native image when it comes to security. So one thing is, as Fabio mentioned, native image compiles your code ahead of time under closed world assumption. So everything there is to know about your application needs to be known at build time. And some people see this as a limitation, but I think it can be also seen as an architecture or design choice, because it gives you those advantages that no longer no new unknown code could be loaded at runtime. There could be no surprises, no bad things happening at runtime, because everything has been discovered and validated during the build time. So this way your application is more secure because there are no vulnerabilities that can unpredictably happen at runtime. And again, as we said, we need to discover everything that is reachable in your application. So when we perform this analysis, we'll look at your application and we will try to find all the reachable code. So all the code that is actually involved in what your application is doing, only that code will be included in the native executable. And this applies to everything, to your own application code, to your dependencies, to your JDK classes. And then, for example, if you're using some dependency that you're not so sure about, and you're using maybe just a fraction of it, only the things that you are using will be included in the native executable. How cool is that?
Yes, very, very cool, and we're actually building more tools around this. So one of the things that you can get with GraalVM native image is an SBOM support. So we can create an SBOM for a software bill of material of the dependencies that ended up in your executable, and we can even list or provide a list of all methods and types included in the executable. So if there is a vulnerability, you can actually go and check is the vulnerable method included in my executable, and only then you really need to recompile, rebuild your app. But if it's not there, then you're good. It's not included, yeah, you're off the hook.
Yep. And the next one is also a fun one. So you might have heard that GraalVM doesn't support reflection. That is not true. GraalVM does support reflection, but there are things to know about it. So reflection needs a specific configuration to be working with GraalVM in most cases. In some cases, native image will figure out reflection on its own, but in many, many cases, it will need an explicit allow list, which doesn't mean that it should be coming from you manually. This could be coming from the framework, library, etc. But there is more control over reflection in native image because reflection needs to be configured explicitly, so by yourself, by your framework, library, etc. So again, no unknown, unpredictable reflection happening in GraalVM.
Yeah. Well, I wouldn't necessarily say reflection is disabled by default. Like for a normal type, reflection is disabled by default. You can't look it up reflectively. But if you're doing reflection, simple reflection, for instance, class for name, and then you put in a string, the analysis can completely replace that with the actual class during build time. So there's not even any reflective code anymore at runtime. And the analysis can do a bit more than just that. It's very smart. But the moment you put in something like, I don't know, a system property, or even crazier, and people do this sometimes, resolve a class depending on user input, right? Then you may end up with a bunch of classes that a user can possibly access, and those need to be explicitly listed in a reflection configuration. So you have to tell native image, these are the classes that I want to make reflectively accessible in my application, because you know which ones you want to be part of this list, but then you can't have these like unpredictable reflective calls in your application, which makes this whole thing more secure.
So yes, reflection works with GraalVM. It does require configuration in some cases, but that configuration is not as scary as you might think. We will maybe show it later on. It gets more complicated for more complex applications, but more and more frameworks and libraries resolve this for you. So this is not something you normally have to worry about. And again, additional kind of security layer coming from this. And same applies to serialization and deserialization, right? So once again, has to be specified so you have more fine-grained control and awareness of what exactly is happening in your application and why. And last but not least, so there are certain attack vectors that target the JIT compiler specifically. So there are things that could be done to it. So this is just not possible in native image. This whole attack surface is not available because there is no just-in-time compilation anymore. Everything is compiled, and in the end, you just have your native executable.
Okay, and lastly, compact packaging. Well, we already touched on that as well. These are numbers from Sean's talk, Sean Smith, that he gave last year here at Devox, where he demonstrated that you can make really small, tiny Docker containers with a Java application. And yeah, if you're comparing, for example, a Debian Slim image with JDK 17 in there, it's something like almost 400 megabytes. But a native executable of the same application is much smaller, and in many cases it's completely self-contained. So it's just a binary that you put in a container. No need to put a JDK in there. It just depends on libc, and maybe you have some other dependencies in there that you like, other external dependencies. But we also support, for instance, static linking, and then you can do this, for instance, with Muscle, and then you can have really self-contained executables that are really, really small and that you can put in a Scratch container. Some folks want to get it really, really small. You can also compress these executables still. Some folks have used UPX for that. We're also working on other compression strategies, native image-specific compression strategies. So in the future, we expect images to get even smaller. Right, and then these are great to deploy because you don't have to send 400 megabytes over the wire. It's just 5, and it's self-contained. It's easier to maintain your deployment pipeline.
Yeah, so this chart is from Sean's slide from last year's Devox talk. It's very good. So if you have questions around, what's the best image to use with GraalVM, how can I containerize my applications, etc., it's in very tiny font there. But like, if you're curious about that, that's a very good talk. You can find it on YouTube on Devox's channel. Okay, and what's new in GraalVM? So recently we had our GraalVM for JDK 21 release, something like 2 weeks ago, I guess.
19th, I think. Yep.
I'm trying to count when it was. Yes, about that time. So now we have GraalVM for JDK 21 builds, and that means that you can use all of your favorite features from the Java 21 release together with the latest GraalVM features. So all the latest cool stuff, including, for example, virtual threads from Project Loom. You could have used this before in GraalVM. We had kind of preview builds, so you could use them, enabling them as a preview feature in GraalVM like you would on Hotspot. But now this is all GA in GraalVM, and you can just use it. And we also want to take this opportunity to look and talk with you a bit more about what's in this release, and then we will switch to demos. Okay, so this is our latest release blog post, and this is the thing that Fabio talked about when he said that we see that with native image we can achieve similar or even better performance than you would on JIT. So this was the case for many applications we've seen before. We ran a lot of benchmarks internally, and for many applications that maybe you typically run, so Micronaut, Spring Boot, Quarkus, etc., we've seen IoT performing on par with JIT or better. And now we also have such observations for the pet cleaning application as well. So in the past, we also did these benchmarks, and we've seen that startup, memory, all of that is great on native image, but peak performance in some cases could be a bit behind. So now with this release, GraalVM for JDK 21, here we see that in terms of peak throughput, so the number of requests that you can serve per second, native image performs better than JIT. And for that, there are a few things that you would need to use. We will talk about optimization strategies in a bit in a demo, but generally what we recommend is trying two things. So one is profile guide optimizations, PGO. So that is this collecting profile information of your app and then feeding it to a native image so it can build an executable with profiles in mind and optimize for the specific behavior of your application at runtime. And the other thing we typically recommend is trying out the G1 GC. There are applications that will benefit from serial GC, but in many cases, PGO and G1 GC would be the way to go to achieve the best peak performance.
Right, and while these numbers look very close to each other, keep in mind that one of these uses only maybe half of the amount of memory. So there are lots of additional benefits that you're getting without compromising requests per second. So yeah, you want to go through this?
You can go through it.
Yeah. So this is the table from the release blog post, and so we measured a couple of things like memory usage. So I think we set a max heap
512
to 512, but still you get a max RSS, so a peak memory usage of over a gigabyte. So that means the JVM here has decided to allocate twice as much memory. So in addition to 512 megabytes Java heap, the JIT needs storage, the GC needs infrastructure storage, to store profiling information, to store metadata, and so even if you tell the JVM to use only 512 megabytes, you may end up with it actually using a gigabyte. And with native image, it's down to 641 megabytes. So this also may be happening right at the beginning when lots of stuff is happening. These were the numbers that we saw. Peak throughput is it's 8% higher. But also, and this is an interesting new measure, we also compared the two numbers, multiplied the two numbers essentially, and have this new metric, request per gigabyte seconds. So most of the cloud vendors, they charge in cloud deployments. You usually charge by memory, and memory is the most expensive resource these days. So so you really want to take memory consumption into account, and the moment you do this and you're running with almost the same throughput, but with less memory, then of course you get a much better ratio in terms of requests per gigabyte seconds. So here we are 50% better, and tail latency is also very low, 28% lower, and of course startup time is orders of magnitudes better, from 7 seconds down to 210 milliseconds.
Yeah, it's cool what you pointed out about tail latency, because sometimes you can hear this comment that, hey, I need my JIT system because I need a very good GC because I have my SLAs for tail latency and it can be very strict. So this is my most important performance metric. And typically people don't expect from AUT to also have good latency because, it's maybe biased. But here you can see that even latency, you can get even better on native image, again with G1 GC in this case, but you can get good latency with native image as well. And my probably favorite chart from this blog post is this one. I mean, it's a bit mind-blowing, I'll give you that. So let's look at what's there. So the metric that Fabio talked about, right, requests per gigabyte per second. So how much throughput you can get for given amount of resources per time. How does that correlate to your XMX setting? So here we are mapping that throughput per memory per time on the XMX setting that we ran for our benchmark. And two observations that we can have here. So the blue line, that is C2. So that C2, that is your default OpenJDK compiler. So the blue line, you can think that that's your OpenJDK kind of setup. And then the orange line, that is native image. And two things to point out here is that in general, native image is above C2. So for your amount of resources, regardless of what are the XMX settings, you will get more throughput per memory with native image as you would with JIT, because it still gives you good performance, but it uses way less memory. So in terms of efficiency, how you utilize those resources, native image will be ahead no matter what is the XMX setting. But another interesting thing here, I think, is in the very beginning, so at around 500, maybe 512 megabytes heap, and that was small to medium heap sizes. With native image, you will get almost twice as much throughput per memory as you would with JIT. So if you have small, medium kind of size application, native image will be twice as efficient in terms of throughput per memory as JIT would be. Okay, cool. Should we switch to demos?
Yes, well, we thought, yeah, it's cool that we can share these numbers with you, but since we have a deep dive and we have some time, maybe we are bold enough to try and actually reproduce this now. So, of course, benchmarking is a very complicated topic, and we can't be 100% rigorous here and do like proper scientific benchmarking, so take this with a grain of salt. But we essentially want to show you how you can reproduce this yourself and what we have done to actually make all of this work.
Yeah, and we actually brought a very badass benchmark. Let us show it to you. Just one more thing, because before we transition there, I just want to show once again this Q&A thing. And I will scan it myself so I can monitor questions. But if any point in time, and even now, if you have any questions, feel free to ask us here. Okay, no questions yet. Let's go with the demos.
Okay. Well, so the first thing in terms of demos is the Spring Pet Clinic benchmark. And what we've done here is we've taken the Spring Pet Clinic sample application, which is a really simple, pet clinic application where you can have like owners and animals, and you can, you can create them in this UI, and then there can be visits and so forth. So it's more than just a simple hello world, and it's actually very complicated or complex application that shows you how to build applications with Spring. So we're using this for benchmarking, of course, and what we've done here on our machine, our remote benchmarking machine, is we have just simply cloned that the sources, and we have different, maybe I should increase the font size actually a little bit. Is this okay? Hope so. DevOps 23, AOT. Pet Clinic. So this is the Pet Clinic repository. Yeah, we only added some files, and I changed the POM XML just a little bit.
So for us, this our previous runs, right? We did not do any magic. We just ran our like benchmarks and got charts in advance.
Yes.
That's the delta, basically.
Yes. And what we added is essentially a profile, a Maven profile to create an instrumented image. So we're using PGO instrument here. And then we have another profile to create an optimized image, which consumes that profile. And then we also have a bunch of other, like two other flags. One that enables G1, and the other one allows the Graal compiler to use all CPU features available on this machine. So you usually, typically use march if you are building on the same machine that you're deploying on, or a similar machine, right? And in some cases, well, yesterday in the BOF, for example, we've heard that this is not always very useful because you may have different CPUs in your production system. But in some cases, you do know where you're going to deploy. And then you may want to use the march native flag to really squeeze out performance and get really good performance. We also have an march compatibility mode, which lowers the default. The default is, I think, x86 v3. So if you're not sure where you're going to, like, who is going to run the binary and where, then you may want to run in compatibility mode. So for instance, in virtualized environments, like on GitHub Actions, you may want to use such binaries. So this is that. So essentially, we only added stuff. We didn't delete anything. We didn't modify anything else. We only added these two profiles. And we have these scripts, so these are really simple. I don't want to run them right now because we get to run the actual benchmark, but this is using the GraalVM JDK 21 release, so this is the latest release. And this is printing the native image version, and then we run the usual Maven wrapper native compile with the native profile, and we skip the test because we wanted to increase the build time or improve the build time. So this is a setup without PGO, right? And in the instrumented case, we ran with the instrumented profile, the one that you see down here. It's essentially the same build, but it's adding the PGO instrument flag. And with that, you get a new binary that spits out a profile after you've run the binary. So what we've done is we launched the executable, put some the workload on the executable, and then killed the server, and that gave us a profile, and we used that profile in the last and final step, which
is... So one thing about the profiles, right? So you want to run relevant workloads, right? And you want them to be good. So if you want to collect good profiles and really reflect what application is doing, you need to run relevant workloads for a while to execute all possible code paths and really tell native image what exactly is happening in your application. So as many as relevant workloads as you can run will be very helpful. Maybe you want to run your tests based on the instrumented binary. So it's important that you have good profile information to achieve the best peak performance.
Right, and then finally we run with the optimized profile, which is what we've seen down here. And this takes in our profile. It's the default iProfile. This is the file. This is the profile that was created. And it also adds the image option and the G1 option, and then spits out another executable called artifact ID and then optimized. So in the target directory, we actually have different executables. There is a Spring Petlinic executable, which is built with a normal built native script. Then we have an instrumented binary, and we have the optimized binary. And of course, we also have the jars so that we can run on the normal OpenJDK.
Okay, so let's run and compare what will be better.
Yes. So let's see. Oh no, we can run. Yeah, we can just run the application first. Maybe that's better.
I mean, we can probably just do the benchmark, but yeah, we can show what it's
doing. So if we're running this on JIT, right, this is now the application starting up, and you can tell this, well, even though this is a beefy machine, we picked, I think, 16 cores and 32 gigabytes of RAM, something that the JVM should feel really comfortable in, right? And you don't need this big of a machine for a native image executable.
But we are trying to be fair to the JVM, so it's not like we are limiting JVM and putting it in a very small machine where it cannot really shine, right? So we are giving JVM a fair fighting chance against native image.
But even in this setup, Spring Petlinic took more than 5 seconds to actually start up, right?
I mean, it's a bigger application and it has a database and everything. So
But 5 seconds is a lot, and
we don't have such a patience, so we also have it compiled to native.
Do we have this thing
forwarded
already?
It should be on, I hope. We can look at the ports, but
nope. It's 8080, right?
Yep. Yeah, you need to kill those.
Okay. So do some port forwarding. And here's the Petlinic application.
So this is pretty much a standard for benchmarking Java apps, right? Because it's quite advanced data, multiple endpoints, and we wanted to bring you something as close to the real world as possible to show you that on a real world kind of like application, not just on a hello world, how we can achieve good peak performance.
Right.
Yep.
So the first thing that we're going to do is, instead of running Spring Petlinic on hotspot, we are going to do this in native mode. AOT, Spring, okay. So we can run native, and we can run the optimized one, it's fine. So this only ran the Petlinic binary, and we're already setting a max heap. We get to this in just a bit when we talk about the benchmark. And this is the same application but compiled to native. And it started in 156 milliseconds.
Yep.
Right, so this is much faster, and of course
we can check that it's doing the same thing.
So it's actually doing the same thing. It's still running here, and it's the same application. Okay, so far so good. So now, this thing, now we want to do some benchmarking, and this application has some endpoints, some REST endpoints, and instead of like setting up a hello world and just
bombing it with requests.
Hitting that one with a lot of requests, we actually have a decent benchmark setup that I'd like to share. So we are using Worker, which is quite a popular project on GitHub. There's Worker and there's Worker 2. So this is the HTTP benchmarking tool that we're using, and this is pre-installed on our machine. And one thing that this thing can do is it can be scripted. So we have a script that can emulate or create a certain workload on the server, and then we can say from the outside, like, how many threads do we want, how many connections do we want, how many requests did we actually send, and what's the request per second ratio. And the script that we're using is this one here. So it's actually a Lua script. So don't be too scared. It's really, really simple. We have this is like the endpoint, and then we have different pet types. We have some different request types. So these are like string templates essentially that we're gonna use. And then we have some setup. We need some sort of thread ID counter. And then eventually we get to this point where we define requests. So the way this works is first it starts with the state -1. So this is essentially like what kind of request we're going to send. -1 is doing some setup just to make sure that this works, but it's not that important. And then we get to state 0, which creates a new owner, right? And then eventually we get to state 1, which creates new pets for the current owner, right? And then we get to state 2, where we navigate to the owner page to query the data for the given owner. Then we go to state 3, where we visit the current pet page. So essentially, we are writing data and we're taking out data. And then lastly, we also go back to the owner page, and that's the whole benchmark, right?
So as you can see, it's quite advanced. I'm personally very proud of this benchmark because we try to make it as realistic as possible. So this, I hope, looks like something you could be working on yourself, where we hit different endpoints, populate the application with data. So we tried to reflect as much real-world behavior as possible to show you how your actual production application could work like on native image.
Right, and to be fair, the script is already public, but it's not easily accessible. You can find it in our repository if you're looking for benchmarks, but maybe we put together a benchmark repository where you can find this more easily, and reproduce this. So this is the script that we're using, and the way we're using this is we created these benchmark scripts. So this is just infrastructure to do some printing. So we start with starting the pet clinic application. We're doing this again on GraalVM JDK 21. So to make sure that we're not cheating, we're actually using this Java home bin Java, right? And this flag here turns off our Graal compiler. So in the GraalVM JDK, Graal is the default compiler, obviously, because we need it for native image, and we also want people to use this, not just to test the workloads, but also to deploy them in production. In this benchmark, we actually want to compare to C2. We have another script here, you can already see it, that runs the same workload on the GraalJIT, so it's identical, except that the flag is not there. So here we're setting a max heap to 512 megabytes, right? And then we just say, okay, jar, and this is the pet clinic jar. We run the whole process in the background, and we keep track of the process ID. And then in the next step, we start this PS record thing on the process ID. PS record is a nifty little tool that creates nice graphs.
And it's very cool because it shows you visually things you want to see, such as CPU usage and memory usage. So we will see that in a second, but it's very kind of visual representation of what is happening in your program.
Yes, so it can keep track of memory and it keep track of CPU usage, and we have extended it a little bit so that we can adjust the axis. But
that's funny, right? So the reason why we needed to adjust the axis is because native image uses so much less memory than the JVM that if we were to put them on the same axis, it will be very hard to even read that because the difference is so huge, right? So we needed to tweak just a little bit the script to adjust the scales for native image to properly show the numbers.
Right. So what this essentially says is use PS record on this process, create a plot. We're using like the date, timestamp, and then we append JIT C2, and then we say, okay, x-axis, y-axis for CPU should be 1600. This machine has 16 cores. That's why. Right, and then max memory should be 800. We've ran it a bunch of times and figured this is a good value, even for a max heap of 512 megabytes. There are some processes in the forked, and we need to keep track of the. We want to keep track of those too. So that's why we have this include children flag. I think we also run PS record in the background. And then we sleep for 10 seconds. Why? Because we want to show you that there is some startup happening. And if you remember, starting up Spring Petlinic took already 5 seconds. So waiting 5 seconds was a bit too much. So we thought, yeah, 10 seconds is fine. We'll never hit that one.
But
and
once again, giving a JVM like a good proper setup, right? So we are warming up the JVM, giving it a chance to shine.
Not yet. Now we are still yes.
In the warm-up run.
We are starting. We're giving the JVM time to actually start the application, right? And then once we are done waiting for Petlinic to actually come up, we hit it with the workload for 10 seconds. This is our worker, and this is the script. So this is where we're warming up the application. Right, with just one connection and one thread. We can scale that, but we don't need to in this example. And then we exercise Spring Petlinic with the same script, but for 20 seconds. So this is how the benchmark works, right? We start the application. We use PS record to record memory and CPU usage so that we get nice plots. Then we wait 10 seconds until the Spring Petlinic has service is up. And then we hit it with a workload for 10 seconds to see we get to see some warm up, and then we hit it with another 20 seconds to see hopefully some sort of peak performance. Again, this is not rigorous benchmarking here due to time constraints. We don't want to do a proper benchmark for hours, right? Internally, I think we run the benchmark for 10 minutes, so not just for 30 seconds or 20 seconds. So so the numbers that we share are usually not based on like a 30-second time span. Then we print done, we kill the process, we sleep for another second so that we get proper output.
Fabio, we apparently got quite a few questions while we were going through this, and I guess we could answer them afterwards, but also it's quite a few, so maybe let's try it now.
Okay, sure.
Sorry for stopping you, but I feel like there will be more questions as you run the benchmark, so
yes.
Yeah. Okay, cool. So are PGR profiles cross-platform enough, or should each target be instrumented separately? I think they are kind of cross-platform. Not sure if like 100%, but you can use the profile on different platforms.
Well, you can use profiles on other platforms, as far as I know. But I
mean, ideally, you want to execute on the platform because some things about JDK, etc., can be specific. So.
Exactly. I was just about to say this. So everything that like is not a proper match will be discarded, and if there is some, I don't know, if there's something platform specific like AWT or something, then you may have a profile for AWT stuff on Linux, but that profile doesn't work on Windows, and then AWT is just not optimized in that sense. So you can do this, but I personally wouldn't recommend it. Yeah.
So preferably if you have a chance collect on your target platform, this could work, but if you really are aiming for the best peak performance, the best profiles, you would want to do it on the target platform.
Okay, next one. Can we use unit tests for profiling? That's a fun one. Because unit tests are not often representing a specific workload, right? And well, you can use it for profiling, sure. It's probably better than nothing. Go and measure. but it's probably best if you're hitting the application with a representative workload that you would see in production, because yes, you can optimize it for testing, sure, and maybe you're also hitting the right main entry points in your application that could benefit from profile guided optimization, but it's probably better to hit the service or the executable that you have with a realistic workload doing instrumentation.
Yep, and the next one is why not let collect profile on the prod environment for a while, like collect it only on one instance on Monday from 8 till 12. So indeed, if you have a deployment with multiple instances, one possible strategy would be that you deploy some amount of normal native executables, and then you have some instrumented ones, you collect profiles, and then when you have enough profiles, you just rebuild everything with the profile information, and in the end, you have really optimized versions, all instances optimized for the best peak throughput. So this could work. Like, it's up to you to define when exactly you have that relevant workload that is really representative of what is happening. So maybe if you have, I don't know, online store, media, website, etc., maybe indeed Monday morning is your time to go. But yeah, like collecting on the fraction of your deployment instances, that could be a good way to go.
Yeah, one thing that you could do is if you have 10 deployments in your cloud, you can do 9 without like profile guided optimization, but you do 1 instrumented, and then it's just an example, right? And then the load balancer every 10 times it will hit the instrumented image, and you get realistic workload without compromising too much. The performance of an instrumented image is degraded, but it's not like completely unusable. So if that works for you, then you can collect profiles in production, and then eventually stop profiling. I'm not even sure you need to do like from 8 to what was it to 50.
Well, I guess it depends on them when they see the most peak workload, right?
Yes. So, but eventually, once you're done with the profiling, you can kill the instrumented instance and replace the whole deployment with maybe 8, so fewer instances of optimized images. So that's something that you could do.
Yeah. And the next one was that our blog post that we shared in the beginning was showing a comparison between the JIT of GraalVM CE, though I think it was JIT C2, right? But okay, let's say it was CE, and native image of Oracle one. But do you have the comparison between JIT and native image in GraalVM CE? So if I understand this correctly, you're asking about GraalVM CE JIT and native image CE, right? So both versions of GraalVM CE. So when it comes to peak throughput, GraalVM CE JIT will give you good peak performance because it's JIT and the Graal JIT, so it's good. Ideally, you would use Oracle GraalVM JIT because that JIT has a few more additional optimization phases, so it will give you even better peak performance. When it comes to native image in CE, it will give you fast startup, low memory usage, compact packaging, security, etc. But if you also want to have on native image good peak performance, most likely you would need Oracle GraalVM because you want to have PGO and G1. That is basically the combination that you want for your peak throughput.
Right.
I hope that answers it, but also if I got a question wrong, feel free to ask again and we can elaborate.
Yes. Next one is how to find out which code paths are missing in your profile and in your profiles, I guess, on
That's
profiling.
That's a good question.
Yeah, it's a good question. You can merge these profiles, so you can run the application multiple times and merge them into one big profile that you can then feed into the native image builder. But yeah, I guess you find out if like one of your endpoints or one of the things that you want your executable to do is not performing well enough, right? And
I mean, ideally, we would have showed you that like we have enough profile information collected, but it's kind of hard to really be sure about that assumption.
I also want to mention that we are like the GraalVM team is in Oracle Labs, and we are still doing lots of research. So one of the things that we also are looking into at the moment is to use these profiles to help developers with more, and maybe even visualize the profiles on top of code, so you get to see like what are the hot bits in your application from within your IDE, so that you get additional benefits out of these profiles.
Cool. And is it possible to use JLink to create a minimal runtime with Graal JIT? Yes, absolutely possible with the GraalJet.
I think that was in...
Sean's talk.
I think we launched this in the GraalVM
Oh, that was a while ago. That was
JDK
like
17 release.
A while ago,
forgot.
like a year, 2 years ago.
Yeah. Well, we support JLink.
But you should just Google JLink, maybe it will be easier.
GraalVM JLink is probably enough. Yeah, 22.3. So that has JLink support.
Yep.
It was working before, but we forgot.
Now it's definitely working since that
yeah,
release.
it wasn't using the GraalJet after JLinking, but since 22.3, there's proper JLink support.
The first tab.
The first tab?
Yep.
All right. Okay.
Have we benchmarked applications with Kafka streams? I don't think maybe we publish something internally, but not externally. Let us talk to our performance team and ask if this is something we can publish.
Yeah, I'm not sure we do.
Maybe we do. We would need to check, but at least this is not something that we published yet. So we typically focus on publishing benchmarks for kind of frameworks and microservices and typical cloud deployments, because that's where we get most of questions, right? So how fast would be my Spring Boot, Micronaut, Quarkus, etc. application on GraalVM? That's what we focus on. But that's a good point. Maybe we can look into this and see if we can publish it.
Wow, this is working really well, but I'm afraid this turns into like a massive
cliffhanger. Let's maybe just super quickly go through the rest, and then we can finally go to some benchmarking.
We get new ones all the time, which is good. So keep those good questions coming. Is it possible to compile to native image from classes jars? Of course. Well, the way we design the bin native image executable, if you will, that you use to compile applications is it's supposed to be just a replacement for bin Java. So instead of, like I showed you in one of the scripts where we're building the application, hang on, we run it here, right? We run it on the JIT. Nope. I meant this. So yeah, if you replace bin Java with bin native image, well, you shouldn't probably put that flag in. I don't know what would happen, but if you do, it will compile the application to native. So it's a drop-in replacement, and it supports the jar flag, it supports class path, and it supports the module path, of course, and it supports mixed mode. So yeah, that's
an interesting point, actually. So we try to make your user experience with native image as much Java-like as possible. So our goal is that like anything you can run on Java and then pass your applications flag, etc. We aim to give you the exact same experience on native image, so you can just do native image and do all the same commands, flags, etc. So we want it to be kind of drop-in replacement for your Java execution.
Yeah. Plus, we allow you to do specify some things up front. So, for example, setting a max heap, you can do this later, like when you start the application, but you can also hard code the max heap into the executable, so there's no way you can mess it up in production, right? So that's also something that you can do. So almost everything that you can specify at runtime, like Java properties and environment variables, you can also essentially tell native image to consider them constant at build time, and then it will use that additional information to run more optimizations.
And I think I accidentally marked another one as red one. It was, can you profile a web application? I think it was, or something. Well, I guess you can. Like,
you can profile everything, including
as long as it's a Java application and you control it and you can hit it with the workload and then replace it with the optimized one, yes.
Did you take measurements of Petlinic project or another service inside a container? I guess we sometimes do. The machine that we're using is not a bare metal machine, so maybe that also already counts as some...
container poses some kind of restrictions and challenges, right, in terms of benchmarking. Maybe, again, this is something we can look into and publish with the next release book post. Yeah. Thank you for that suggestion. And as far as containers go, we will have a very interesting kind of upcoming announcement / feature to make in the end of the talk. So there's another cliffhanger. We will have something to say about native image and running them in containers.
Okay, and then can the profiling information be reused after code change, providing it is limited, or do you need to collect new profiling information for each build? Like I said before, like we essentially ignore the profiling information that doesn't match what we see during build time, and that means, if you're touching a performance critical piece of code in your application, then yes, you may want to create a new profile, but you don't have to.
Also, you can merge profiles, I think, from different runs, right?
Yes.
So
Yeah, you can merge.
a lot of PGO questions. I think
Yes.
our team and like Eric over there would be very happy to see how people are interested in PGO.
Yes.
Okay, I hope this is all for now for questions. We are very happy that you ask so many questions.
Yes.
Keep them coming, but we finally want to show you some real-world benchmark. Let's do it.
Yes, so yeah, hopefully no one has forgotten in the meantime how the setup works.
So the setup was that we will now compare performance of our pet clinic ahead of time compiled as a native image versus C2. And when we say C2, you can take it as OpenJDK. We are focused on compilers because we work on the compiler, but every time we say C2, you can just think OpenJDK. So now we will try to compare performance of native image versus basically OpenJDK JIT.
Okay, so I'm running the bench JIT C2 file that you see on the top, and we can start from the beginning. So this is starting Spring Pet Clinic. PS record knows to attach to this process. We see Spring Pet Clinic doing its thing, coming up with a banner, and then there's a couple of things that need to happen. Eventually, the application is starting up. Lots of information here. Yep, started up in 5.3 seconds. Done waiting for Spring Pet Clinic to come up. Now we are warming up the benchmark by hitting it with our workload for 10 seconds. You can see there's additional output from the service because it's it has received some request.
So we are hitting it like for 10 seconds. We are hitting it with all the requests it can handle, right? That's the workload. So you're not setting the number of requests, but like for 10 seconds, like show us what you got.
Yes, and what we get is something like 417 requests per second, which is not a lot, but this is happening in the first 10 seconds.
And this is the warm-up run, right?
Yes, and then we do this again for 20 seconds, and then we get to 1,444 requests per second. So that's a lot more, but what you can see is it really takes a long time for Spring Pet Clinic to warm up. Like I said, in our benchmarking infrastructure, we let this run much longer. I think.
I'm sorry for this.
Yeah.
Okay, I feel like I will need to click this every hour.
Yeah.
Okay, so our picture report here for the actual benchmark run was 1.4K requests per second for C2 JIT, right?
Right. So now let's go and run the same benchmark, but on native. So this is without PGO. Right.
So we run this one on Oracle GraalVM without PGO. It's just plain native image.
Yeah, just plain native image. And of course, the application starts up much faster, and it's kind of wasteful to wait for 10 seconds here. But eventually, yeah, we're starting to hit it with our warm-up workload, which you will see is not really necessary. So this is without PGO, right?
Yeah, and this is, I think, interesting because also yesterday we had this question in our Bob from Sebastian Deleuze from the Spring Boot team. It's like, if I don't do PGO, what will be my performance like? Because it could be indeed that in some cases you don't want to do PGO, or maybe you cannot. And like, what is the performance that we can give you out of the box? And the thing there is that, you know, it's very hard to beat JIT, a dynamic system, without PGO. But we also have a very good compiler, the Oracle GraalVM JIT compiler there. So hopefully performance will be comparable. And as I was talking, we see the actual results, right? So on JIT, it's 1.4K per second. And then on native image, without any boosters yet, just plain native image, it's 1.2K.
Yeah, but what's also very interesting, I think, is even in the first run, in the first 10 seconds, we are immediately at this performance, while the C2 setup is 3x slower, right? And that's without doing anything but using just a normal native image from Oracle GraalVM. This is actually using some sort of profile already. You want to talk about this?
Yeah, I can talk about it. So again, we think you should always use PGO if you're aiming for peak throughput, because you need the profile information to build a really performant native executable. But in cases when you don't want or cannot do PGO, we can offer like normal PGO. We can offer you the next best thing, and that is that we have a machine learning model included in GraalVM compiler and native image, and we will predict the profile information of your application as best as we can. And then we will use those predictions to optimize your application for the runtime performance based on this profile information. So this will not be as good as your very custom run provided for your own application profiles, but this is the best guess that we can get when there is no profile information available at all. So even if you are not doing any PGO manually, but you are running on native image in Oracle GraalVM, it will pick up this ML provided profiles. And in other benchmarks, what we see was this ML profile information available, we see 8-10% peak performance improvement just coming from this.
Yeah.
So if you don't want to be bothered with collecting and then rebuilding optimized native executables, just out of the box with this enabled, you can get 8-10% better performance.
Yes, and one of the things that we want to do in the future is not just ship like a generic profile model, if you will, for a JDK, but for specific applications like Spring or Micronaut, Helidon, Quarkus, and then you can benefit from this even more without having to do any PGO yourself. But yeah, as we can see here, we are not quite there yet. We can't beat the JIT without a specific user-provided profile. But what we should look at is are those graphs. So we now end up with two new files. So this is C2, and here's the native run, right? And maybe I should make this a bit bigger and get this out of the way. Okay. So the native executable is using our serial GC, which is, by the way, also entirely written in Java. And as you can see, it has a very different memory behavior compared to G1, which is the default on hotspot, and that's what we see on the left. So what's kind of interesting is, of course, remember we start the application, wait for 10 seconds. So in the first 5 seconds, Spring needs to start up, and yeah, there's some work that needs to be done, not just in the interpreter, but also the C2 just-in-time compiler kicks in, needs to do its work. So imagine this is part of like a deployment in the cloud where you do this like 1,000 times. This will happen 1,000 times, and that's kind of wasteful. Whereas in like the native image setup, we're doing this at build time, and then we only do this once, right? And as you can
maybe just to explain a bit what's happening there, right? So the vertical red lines, that is CPU usage, right? And the blue horizontal one, that is memory usage. And you can see how much more busy CPU is basically all the time during the application run, because it needs just-in-time compile your application, right? And then if we look at the memory usage, so the blue line, you can see that on the JVM, I would say it stabilizes at around 700 megabytes, while on native image, it barely hits 300. So 2 times less, and then if we wanted to, we would not do it now, but we could even limit native image significantly to a very small memory usage, and it will still work, be operational, get the work done.
Yeah. And remember, this machine has 16 cores and 32 gigabytes of memory, so this is something that the JVM should be really should feel very comfortable in. And still, native image performs better without using as many resources. So the native image warm up is this, right?
We really need to zoom in because you can barely see it.
Yeah, so this is it, and then we're just waiting for 9.8 seconds.
Just waiting for the JVM.
Yeah, we just want to be fair, give it some time to catch up. But yes, the performance of the application is not as good, but it's using like half the memory, right? And that means I can deploy the app on the right 2 times.
But also I want to stop for a second and give proper credit to native image and the work it does, right? Because it's very hard to beat JIT, because JVM is an amazing piece of engineering, right? It has been developed for many years. It's really great, and it executes your code dynamically, having profiles, having multiple GC options, etc. So even the numbers that we've seen so far without any boosters, so PGO, G1 GC, even now being like 1.3K versus 1.4K requests per second, so almost on par with JIT without any boosters yet. I think this is pretty impressive for an IoT system that compiles everything ahead of time and doesn't have the the luxury and the resources that the JVM has at runtime. But I believe we can improve it even further if we do PGO on G1.
Yes. So let's go and run. Let's go and do another run. How am I going to do this? Okay, we do a third one. It's fine. So we run the native optimized image, and again warms up really quick. We let
So
this
that will
run.
be with PGO G1 and a Mark native, right?
Yes. So what do we expect? We expect a memory usage around 512 megabytes, because G1 likes to make use of all that. All the space that you give it, and we don't expect a big overshooting too much. We don't want to be in the 700 megabytes because there's no JIT, and native image can keep the promise of like 512 max heap that we've set much better. We also expect better throughput, and we can already see this in the warm-up phase. So this is the warm-up phase, and in the warm-up, and of course. Well, there's no warm-up. There's no warm-up.
That's a good point, right? So I like how the Sprint people call this. So they call this instant performance, right? So like from the very first milliseconds, you already have your performance. There is no warm-up curve. So you kind of have this instant performance.
So let me see if I can get maybe I put the done on the very last line so you have a chance to compare them side by side. So this is after warm-up, okay?
Cool.
So and here we are faster. Right, 1.8K compared to 1.4K. And let's try and pull out the generated graph. Okay, get this out of the way. You want to take a quick look at the questions?
I will. I just want to wrap up this section and then we will. Yep.
Okay. Well, maybe there's some questions right on this that we can answer now, but we can always come back here. So as you can see, memory behavior is a bit different. Warm-up behavior is almost the same. There's more. The CPU load has gone a bit higher. Not as much as compared with C2, of course, but generally throughput is much better. And again, we're using less memory. We could probably go down to 256 megabytes and still see decent performance.
Even less, I think, right? So if you really want to, minimize the memory, you can go even lower, maybe.
Yeah, well, we measured 512 as like a sweet spot, right? Which is why we picked this value. But what we could do is we could run this on a machine with just a single core or maybe two cores, and cut down the operational costs.
Cool. So I hope you liked our benchmark, and I hope you convinced you that you can have good performance with AUT. We do have one question. Well, I guess now it's two since I checked. So can I have custom written class load that dynamically adds jars to a class path? I guess this is in native image?
Yeah, so generally everything that you can do at build time, we support, including agents and stuff. If you have a custom class loader that tries to load stuff at runtime, then that's a bit difficult. But you can make it work by moving it into the build time.
Build time, yeah.
Yes.
I think Alibaba had this contribution that I wanted to make about like dynamic class loading on native image, right? But yeah, it's kind of tricky and definitely not at runtime.
We also have a couple of forward-looking things projects that we are working on, which could make this possible in the future. Could any existing Java application be converted to a native one?
I like it.
Yes, I like that too. Well, this is about...
Well, it can. The question is like what it will take.
What will it take? Yeah. So we want to get to the point where you can do this with any application. GraalVM has been used in lots of microservice frameworks, and it's actually they come with built-in support for GraalVM, but of course you can use native image for more. I personally have an application that uses AWT, and that works. The user experience is not as nice because AWT does a lot of JNI calls, and there's lots of reflection going on. We have a research project that tries to make this better as well. It requires lots of configuration, but again, we have tools that help you do most of the work for you. But yeah, compatibility with the rest of the Java ecosystem is of course one of our top priorities, and we keep pushing that forward. Some of the things can't work, like we can't support agents that try to change bytecode at runtime, because there's simply no bytecode, right? There's nothing that you can do at runtime anymore. But what Alina just put up here is our ready for native image page. So if you go to graalvm.org, go to docs, and you can find libraries and frameworks here. And this is supposed to give you an overview of the things that are supported with GraalVM and native image. So as I already mentioned, Micronaut, Spring, Quarkus, Helidon provide first-class GraalVM support. They also provide configuration out of the box and an out-of-the-box user experience. So if you are using one of these frameworks, you should be good. They should already have done the heavy lifting for you. It's not always heavy lifting, but usually if you're using frameworks, they tend to call into you, and then they make reflective calls, and that needs to be properly supported. But in addition to that, we see, and we're very excited about this, we've seen lots of libraries adding support for native image by shipping configurations as part of their jars. That's the best way to really support native image. So here's a list of libraries and frameworks tested with native image that we put together with the community. So 2 stars means the library or framework is continuously tested by its maintainer, so they run the test and provide configurations themselves with native. And then we, of course, also allow the community to step in for libraries that are not ready or don't want to support GraalVM native image just yet, to provide configuration as part of our GraalVM reachability metadata repository. So yeah, maybe I should scroll down that list real quick. But yeah, the list of libraries. Well, there's Micronaut in there, but there's also other libraries, like lots of Apache libraries, Eclipse libraries, Hibernate. There's Spring. But this list is constantly growing. And if I quickly click on that link, it will take us to our GraalVM reachability metadata repository. So this is a place for developers to share configuration. We don't want to bore you with configuration today too much. You can find guides on our website that help you get started. And we also have a contributing MD in here that helps you, explains you what you need to do to get your library in here. Well, if you have your own library, then you probably want to, like I said, put this into your jars. Then it gets automatically picked up. But what we can do here is also retrofit configurations for already released dependencies.
Yeah, so to summarize this, quick way to evaluate whether the application will easily compile to native image is the following. So if you're using one of those frameworks that we showed before, Spring Boot, Micronaut, Helidon, Quarkus, most things will just work. Then if you're using dependencies, our page on the website will give you an idea of how likely it is that the dependency already works with native image, and that will be the easiest way to go. Now, if you're doing a lot of custom reflection, etc., it might get tricky, but the good thing there is that just yesterday after the BOF, I was talking with one of the community members, and he mentioned to me that he converted an AWT application to native image, and it was quite easy, actually, he said. So the tracing agent that we have in native image helped him produce the full config that he needed, so he didn't need to do any manual config at all. So you just run an application on the JVM with a tracing agent, you execute the code path, so maybe for kind of desktop applications, you would need to click elements, etc.
This is where you want to use your unit tests.
Yes. Yeah. But the agent was super helpful, so all those scary JSONs that maybe you have seen sometimes for the configuration, this is not something you would need to do normally yourself.
Yeah, and coming back to this reachability metadata, like if you go to the metadata subdirectory, you can see this list again. It's essentially the one that you've seen on the website, plus some more libraries. So we get lots of contributions from also the Spring community and the Micronaut community, and engineers. They are contributing a lot here, and we're very grateful that this is turning into a very popular project. There's 19 open pull requests. I should be reviewing
but
more.
250 closed, so more closed than open.
Oh yeah. Yes, there's a lot of contributions coming in, and if you have a library, if you maintain a library or framework, and you provide support for native image, you can add your library to this list, and together with the metadata directory and this JSON list, we actually that's actually the source for the website that I've showed you. So it will. Where did I go?
The pinned one. Yeah.
The pin. Oh, right. Yeah. So the next time we update our website, your library will be listed here as well. So
Okay, Fabio. I feel like we should give people a chance to grab coffee and breathe out and make a short break. We still have a lot of content, and we hope it will be less scary stuff. So it will be fewer benchmarks, but more practical things about building, testing, deploying, monitoring your applications. Yeah. So maybe we can take a 10-minute break, and then we'll promise less scary benchmarks and more practical, cool, and fun things.
I've got an idea. While we're at the break, I'll run the benchmark again with a GraalJIT, not with C2, and we'll take a look at that when you're back.
Okay. So let's see you in 10 minutes. Thank you.
Okay.
Oh, that was simultaneous. Welcome back. We can proceed. And in the meantime, as you were on the break, Fabio spent the time doing work, and he wants now to show us the GraalJIT performance. Yes. So the GraalJIT compiler in Oracle GraalVM.
Yeah, so that's what we can see on the right-hand side. This is where we run the same benchmark again, but without disabling Graal, right? As you can see, it is kind of similar to C2. Memory consumption is almost the same. What's kind of the CPU usage is a bit different. Performance, though, is almost the same. Let's take a look. There's also some warm-up.
Basically the same as C2 JIT, right?
Yeah, as C2 JIT. But what I find really cool is that the JIT, like Graal, can beat itself in AOT mode, right? So like even the same compiler in JIT mode is not as efficient as in AOT mode. And if you're wondering what's going on here with the memory consumption, it's also a really cool thing. The compiler runs in multiple threads, and it can also, when it's not busy, can also free up memory. And this is probably, I'm guessing, compiler isolates shutting down and freeing up memory from time to time. And so eventually, when you reach peak performance, the compiler can completely offload itself. And also, these isolates, they don't crash. So if there's a problem in C2, it will probably crash your whole application. But if the Graal compiler fails, maybe some method may not be optimized anymore, but at least your application will continue to function.
Yep. And we should move on, but I want to say a few words about the GraalJIT, right? So it's also a very good JIT used by many teams, organizations as a JDK. So I hope we will publish soon a blog post where Oracle NetSuite, so one of our internal teams at Oracle, is using GraalJIT just because it's so good. Also, if you have a code that is doing a lot of abstractions, so maybe more modern Java, or if you're running Scala, maybe you will see very good performance improvements from the GraalJIT. Right. And with that, maybe we should wrap up this benchmarking section, because I feel like this was getting a lot to parse. And we also want to do something a bit more fun and entertaining. So Fabio and I tried to do some prompt engineering, doing the cool stuff. And we asked Midjourney a couple of questions about GraalVM. And here is the output, but we want to try you to guess what was the prompt. So what do you think this is supposed to be? And the hint is that this is obviously related to GraalVM somehow. So what do you think we are looking at here? You can just shout out your suggestions.
Java developers running Graal.
Found Graal?
Finding
Graal.
That's
a good guess.
Yes. Well, some of you may have heard of Project Galahad. And we actually used this prompt: Knight Galahad holding the Holy Grail on Java Island.
As you can see, it's quite advanced. So Midjourney is not as smart yet to, show the Java island in some meaningful way. But this is the best it could do.
Oh, come on! There's some water here. There's an island.
I mean, you can argue that it's an island, right? Yeah. But it's the best it could do. But I think it's pretty cool. And then the project Galahad itself is this project where we announced how exactly GraalVM will be more integrated into the OpenJDK mainline.
Right.
Maybe we can do one more just to stay on this.
Yes, we can do one more.
Note.
What do we have here?
Oh, this is a good one. Okay, I don't know if you've seen our mascot, but maybe you can also try to guess what is happening here.
Anyone?
Nope, this is just too crazy. So here's the prompt.
Yeah, the prompt is the GraalVM rabbit on the train to Antwerp with a laptop.
So we have Grabbit, our very cool mascot, which doesn't look exactly like that, but it is our mascot, and the name is Grabbit, which actually Fabio came up with because the GraalVM rabbit, and I think it's very cool. So Grabbit it is, and this is our Grabbit. Yeah, and we'll actually have it on our t-shirts. Yes. So this is Grabbit on the way here to Davos, Belgium on a train.
Okay, so
I hope you liked it, and yes, with that we want to move on to other topics. So we also seen that you asked us quite a few questions. We are very happy about that, but we also have brought a lot of content. So I think maybe we'll try to go through that and then leave 20-ish minutes towards the end for questions, if that's okay with you. So yes, I think we covered that IoT at the speed of JIT, right? And now we want to talk about how would you build your native applications with GraalVM. And for that, we will take an actual application and then migrate it to GraalVM, trying to show you how you would actually move to GraalVM and what are the steps that you need to take. So we will show Game of Life there.
Yeah, we show Game of Life there.
So maybe you've seen this very cool demo of Game of Life implemented in Java. So this is the original repo. We want to stop here, give the credit to the author.
Yeah, I think Elliot Barles is the guy's name. Yeah, he put together some demos for virtual threads in Java that are now GA in 21 and also are available in native image. So this
is a computation-intensive kind of application, right? There are a lot of these computations happening for the
there's
cells.
a lot of computations happening, and every cell is represented by a virtual thread, and it can be very big. I think he has a benchmark. Yeah, this is what this looks like in AW2 window. So every cell is represented by a virtual thread, and you can also do off-heap computation. So I think he has like a benchmark with like 50,000 virtual threads, 50,000 cells. Right, so that ends up being 50,002 virtual threads and lots of channels. It looks like this. So yes, you can compile this application to native with AWT, but we figured this is a desktop application. We want to do this locally, but unfortunately, AWT isn't where we want it to be on macOS. It is supported on Windows and it works on Linux as well. The reason for this is back in the past we supported statically linking AWT, but that is no longer supported by the AWT native parts of the JDK. So now this is being dynamically linked. We've done the work for Windows, we've done the work for Linux. We are working on Darwin, and hopefully soon we'll have that covered there as well. But for this demo, we implemented essentially like a terminal view of this thing. And we forked this, so you can actually go and build this yourself, including GitHub Actions. So there's a fork that you can find on our on our GraalVM GitHub organization. And you can see me here. I pushed an update in November 2022, but with Alina, we updated this to the 21 release. The GraalVM was supporting that before, but now we're using the JDK 21 release. And if we're clicking on this, we can compare it to what Elliot has done. And what you can see here is this is a GitHub action. We'll take a look at that later. We updated the README. So the POM has just a slight update for the Java source level, and we changed the name, adjusted the name just a little bit. And then we added our build tools. So
you can quickly show.
Yes, so that is something that we didn't get to on this page. So at the very end, you can find our Gradle and Maven plugins that you can put into your application, and they will help you to use GraalVM native image and build those very efficient standalone executables with GraalVM.
Yeah, so typically native build tools, Maven Gradle plugins is something we recommend as a step one as you want to migrate your application to GraalVM, because those out of the box will give you capabilities to package, test, build your native application. So typically when you have your existing app, the first thing you want to do is to add native build tools. Also, if you're using one of the frameworks we listed before, Spring Boot, Micronaut, etc., they already have under the hood our native Maven/Gradle plugin, so that's already included. That's very cool. They adopted them so they can kind of pick up our latest changes from native build tools. And then if you want to configure something specific to GraalVM and build tools, you can do so in the native Maven Gradle plugin, that section of your build file.
Yeah. So you can go and take a look at the documentation for the Gradle or the Maven plugin, and in here is essentially the how to register the plugin. So this is essentially what we've done here, right? So if we put this side by side, you would see that this is actually what we're using. There's also configuration for with G1. We have seen those flags before. So this is really simple, just XML configuration. This is not using the latest version of our plugin. The 0927, I think, is compatible with the JDK 21 release. So it's using public API options and stuff. It still works fine with 13, 0913 in this case. And we have different profiles in here, but that's it. I think we talked to, or we did some internal measurements and realized that the linked blocking deck is actually better than the linked blocking queue. Can't remember why, but go and measure yourself. And then we have adjusted the console output. So Elliot has worked on a simple console output, and we essentially made it a bit smarter and added a rate counter and some ASCII, ASCII art, and that's it. This thing is for benchmarking.
So basically what we did, we added native build tools, right? And then the rest is some kind of manual tweaking, but not much. So we just integrated our native build tools. We did not do any config, nothing like that.
Yes.
And this is how we would hopefully now take it to native.
Yes, and I don't want to build this, well, we can build this locally, of course, but we don't.
But we just rebuilt it on Friday, so
but we don't have to, because we also set up a GitHub action. So GraalVM provides a GitHub action. It's set up GraalVM. Let's see the GitHub action. Yes, this is the one. So you can find it in the GitHub Marketplace under Actions, and it provides you with access to GraalVM, of course. It will set your GraalVM home. It will set your Java home. It also works with AArch64. It has some native image features that I get to in just a bit. And there's some templates here. So here's a quick start template. Essentially, that's what I copied, and then I copied the Maven step here. But we also have a self-contained hello world. So here's the hello world in one line, and then you can build this on 3 different platforms and get the binary uploaded, and you can download it. And if you want to do more, you can take a look at all the options. So, and that's what we've done here. We actually upgraded the extension. So this is set up GraalVM. So we run a GraalVM native image build. We set up a metrics. We built on Ubuntu and macOS. We could do this on Windows 2, of course. Then we're using the 21 release. We're using the GraalVM distribution, and we are enabling our reports. These are 2 features that our extension supports. Then we're building the application with Maven and the native profile. So this should be set to native, and if there is, that works. And then we move on and actually do a tiny little benchmark, right? So this uses the time command to run the benchmark on OpenJDK, and then run it with the native setup. And finally, it uploads the binary, right? So now we can go and go to the Actions tab. This is in the upstream repository, but in our repository, you can find the build. Right, and we can take a look, for example, at the macOS build. So this build ran in something like 3 minutes, or 4 minutes and 23 seconds. So the actual build step was 2 minutes and 36 seconds. And this is where, Maven does its thing. It needs to compile the sources, right? And then eventually we get to the native build step. And this is provided by our native Maven plugin.
So I just want to stop there and say one thing about the building, right? So if you're building a larger application, this can take some time because there's a lot of work to be done, right? So there are those 8 or 9 steps of the build process. And if your application is large, discovering what it does and then building it can take a while. But there is a way to speed it up. So as you are still developing your application, you can use the quick build mode in native image by passing the -ob flag, and that will speed up the compilation step. So you will get your native executable faster, but this is only for development purposes, right? So as you're moving on to production, you want to remove that flag because you want to optimize for peak performance. And this quick build mode optimizes for time rather than performance. But if you're still building app and if you for some reason need to recompile it often because maybe you're touching some parts that can affect the native compilation, you can use this quick build mode to speed up the build and get your results faster.
Yes, and then in the next line, it says, oh, we found a GraalVM installation in this GraalVM and a home environment variable. We use this environment variable, this additional environment variable, because it allows you to decouple the Java home that you're using to compile the sources with the GraalVM that you want to use to compile with native. So, for example, Gradle, up until recently, maybe even today, I don't know, it doesn't run on JDK 21.
Nope.
So you can set a Java home to JDK 17, run Gradle on that, and then GraalVM build step can still use 21. And Java provides good backward compatibility, and it's good enough that you can, or it's totally fine that if you're building like a JDK 17 sources to jar and then build that with a GraalVM JDK 21. So that's what's happening here. Yeah, there's some warnings. We introduced experimental options. Some of these will disappear if I upgrade the native build tools. These -h options, we call them hosted options. They are not necessarily always public API, and we're doing some cleanup. We realized we have more than 600 options in Community Edition and more than 1,000 in Oracle GraalVM. And yeah, we are in the process of cleaning up our public API. So these warnings, they're not fatal. They just tell you, please use some other option. And in the next GraalVM release, they may be fatal. And of course, there's also an unlock experimental VM option that you can use in the future as well. Yes, and this is where the GraalVM native image build output actually comes into play. So it tells us, we're generating a game of life executable. And if you're doing this in your terminal, for example, in VS Code or IntelliJ, it would be colorized. The build output tries to figure that out depending on the terminal it runs in. It can also print links. So sometimes in some terminals, you will see like underlines, and then it's actually a link that takes you to the documentation. If this is not supported by your terminal, the build output will print you a link to the doc. So that right at the beginning, so this is the doc to the native image build output. This is a hello world example, and underneath everything that you see in the build output is explained in more detail. So you can go and check that out and to understand fully what you get to see there. But since I worked on this a lot, I know this from the top of my head, we can always go back. Well, this one ran on macOS, and the machine does not support x86 64 v3 because it's virtualized. It's actually falling back to the compatibility mode. So we have lots of these fallback mechanisms in place. I think in the build on Linux, that's not happening. Yeah, so this one is using the target machine x86 64 v3, and yeah, it's using machine learning inferred profiles, PGO profiles. Then yeah, there's some C compiler that we need for linking. This one is building with the G1 GC. The other one is probably building with the serial GC. We can go and check that out too.
Because macOS.
Yes, well, G1 GC is only available on Linux, but it's now available on ARM and x86. Then again, there's a list of unlocked experimental options, and this build is allowed to use 10.58 gigabytes. So the machine has 14 gigabytes because this is a Mac runner, and the Linux runners only have 7 gigabytes. And now you may be like, oh, 10 gigabytes, that's a lot. This is the max heap of the build process. But just because it's set to 10 gigabytes doesn't mean it will actually use all of this. And the native image builder tries to be smart as possible. So for example, when we're doing a live demo here and we have a presentation software all there and a browser running, we don't want the operating system to ever swap these things out because we have a native image build running, right? So the native image builder is looking only at free memory, and if it finds not enough memory available, then it will fall back to use a certain percentage of your machine. So in this case, not much should be running on the machine, and it's setting a max heap to 10 gigabytes. Like I said, if I like the Linux runners, they only have 7. So this is actually just using 5, right? And it only has access to 2 threads. Then we perform our static analysis, and actually every single star that you see in here corresponds to 1 iteration in this analysis, right? If you remember the slide that we showed you earlier, we do an analysis until we reach a fixed point. So after, I don't know, 7 iterations, we have reached a fixed point, and we found almost 3.5K types reachable, so classes and interfaces. And then we build a universe. Like this is an implementation detail that we found would be fun to actually leak out to users. So internally we have a class that's called, for example, Big Bang, and there's a Big Bang going on. We create the universe, which is essentially a representation of everything that's reachable in your application. And then the Graal compiler steps in, parses your methods, inlines your methods, compiles your methods, lays them out, and then we create an executable. And again, native image is not just AOT compilation, it also takes a snapshot of your heap. So this executable is 18 megabytes in size, and 7 megabytes out of this is just the initial Java heap, if you will. And to give users more control and a better understanding of what's actually going on in these 2 areas, the code area and the image heap, we have the top 10 origins in the code area listed here. So a lot of stuff is coming here from Java base. And the second entry is already our SVM jar, which is the substrate VM runtime component, so the garbage collector, for example. So we may see something completely different in the macOS build. And then here, this is actually the application itself, right? So the Game of Life demo is really thin, and it only adds, it's accountable for 90 kilobytes in this application code area, and then we also have image heap objects.
But this is interesting, right? Even for a smaller application, it's not so large. There are so many types and like code to be included in the native executable, right? Because you're building a Java application, so even if your application itself is not so large, native image is doing a lot of work because Java applications are using a lot of things from the JDK itself, dependencies, etc.
And it's something that we hear a lot from people, that build times, they tend to be a bit long. And we get to that later, that we have an exciting update about this. But also keep in mind, we are reanalyzing the JDK every time, and we compile everything every time. But in theory, also in practice, you do this work once at build time and then never on like an instance anymore, right? So if you do this once and deploy it 1,000 times, it pays back.
Yeah, that's a good point, because those are the same things you would be doing on a JVM on every single application start, right? So this looks like a lot, but this is also the price that you will pay on the JVM every time you start your application. And here we are shifting that overhead to the build time. So you would pay this anyway on the JVM only every time you start your application. So might as well do it once at build time and then start very fast when you run an application.
Yeah. Well, if this is not enough, we have a new option, the build reports. You can turn them on, and then you essentially get an HTML file next to your executable with more detailed information of what's included in your image, right? So you can run that. That's an experimental flag that we are shipping with GraalVM, Oracle GraalVM. We also have a security section. So this binary includes Java deserialization. So it is possible that deserialization attacks can happen in this application. You can turn it off, and if you go back to the documentation, it will tell you more about the deserialization. And we also have a recommendation section with things that native image or the static analysis found, or we found, and that you could improve. So for example, here it tells you, this application could benefit from PGO. We have an upcoming new flag that you want to adapt to be prepared for the next GraalVM release. You can also set a max heap up front to create more predictable memory usage. You can use the emerge option, or you can use the quick build mode to create in development to speed up your development cycle, right? And remember how I told you this process figured out that it is allowed to use 5 gigabytes of memory. We find out that it's actually only using 1.1 gigabytes. So this is the peak RSS, right? And so RSS resilient set size. Let's see. Yeah, the portion of memory measured in kilobytes occupied by a process that is held in main memory, so the actual memory usage. And this is a number that we determined that we get from the operating system, right? So this is not us querying some Java API, but it's us asking the operating system about about this process, how much memory was consumed, and it was only consuming 1.12 gigabytes. So there's a lot of headroom in this runner. We have 5 gigabytes, but it's only using 1.12.
And this is actually a good point, because we used to hear that native image builds are long and take a lot of resources, but we build a lot of things, right? So Java applications are large, but also we improve the memory usage. So since a few releases ago, even if you have less than 2 gigs available, which is not a lot, many applications, even like bigger Spring applications, will still build and not fail because of not enough resources, right? So we are working to make the build process more efficient, and even if you have below 2 gigs of memory, you can still build many apps even in more resources constrained environment.
Yes, but we found, for example, that some users are building in Docker containers, and I think by default some of these containers only have 2 gigabytes available, and then they run the build, and eventually the build takes forever. And we have a couple of things in place, like we exit on first out of memory exception, and then tell the user that there's not enough memory, but still sometimes it's like the flags that you're putting in there to set a max heap doesn't actually reach don't do what you think they should. So we added this new build resources section to tell you exactly like what this builder is allowed to use here. And of course you can control memory, and you can control the number of threads that native image is using. So this one has 2 threads available, and the CPU load was almost 2, so it pretty much maxed out all the CPU resources for this build, and then finished the build in 2 minutes and 30 seconds. So this created an executable, and it also created a JSON file and a temp directory. This is something that our GitHub action does for you in the background. And I can show you why. Because if we're going to the summary page, I've turned on the build reports and the GitHub actions, and they're actually underneath. So you don't need to go and search for like the native image statistics in your Maven or Gradle build. They tend to be very verbose and very long. And this is a relatively simple application, so we can easily find that output. But you can also just flip that flag, set an option in the GitHub action. I think they're called native image drop reports and native image PR reports. So you can also request ask the extension to post these summaries underneath a pull request. So you would, for example, see, I'm bumping in this pull request, we're bumping a dependency. Now the application has shrinked by 2 megabytes or has grown by 2 megabytes, right? And then you can reevaluate, do we really want to do this update? Do you want to change to some other, database driver, which may provide a smaller footprint, right? And you can, and these are also linked into the docs. So here, 1.2 gigabytes, that's what we've just seen. If you click on it, it will take you to the same doc, right? And it will explain to you what values you're actually looking at. So, and then lastly, in these builds, we also run the Game of Life demo in a benchmark mode. So here again, this is also printing startup time. So this application starts up in 192 milliseconds. And then it's running with 5,000 virtual threads and 48K channels. It's also running some warm up, and then it's running the workload. We call the starting timer here, and then eventually we end up with something like 80 frames per second, 80 steps per second in this Game of Life simulation, right? And we also see the process used 32 is a CPU time of 32, and in user space 77. And we run the application a second time. So this was on OpenJDK, right? And then we run the native executable, the same application, but now in native mode with the same flags. And this one starts up in 8 milliseconds. Well, you shouldn't really do benchmarking in the GitHub Action Runner because you might get noise from other runners that are running on the same machine, but running them like one after another is good enough. But still, here we're getting 81 steps per second, and this build is not even using like profile-guided optimizations with a user-specific profile. It's just using the ML inferred profile, but it's also using fewer CPU resources, so you get better throughput at lower, and you are essentially increasing CPU usage. To be fair, I think I've seen that the performance is a bit different here on Linux. So this has 65 steps per second in JIT, and in native it's 62. Well, I'm sure we can beat that if we do some more PGO. But we also see see some additional numbers here. So yeah, it's 196%, 193% CPU time. So they were using the CPU a lot because we were really hammering the few CPU resources that this runner provides. But yeah, and I think yes, this is what I wanted to show. Yeah, and then lastly. In this last step, we upload the artifacts, right? In this example, and you can find them here. And I can go and download the one for macOS, and yeah, we put this here. Okay, yes. Okay, downloading. Yeah, continue the download, and now we go and zip it. So yeah, it's now called 2. We just call it Game of Life macOS. Oh, wrong keyboard. Okay, or no.
Is it the old one?
Oh, access denied. Sorry, I'm not on my computer. So okay, so this is the application. This is the binary, Game of Life binary, and we have a bunch of patterns in here because if you take a closer look at the examples, you can choose different patterns, but we don't want to mess with that too much. We want to take a quick look at the binary. So this is the binary, 14 megabytes. And I should mention this ran on an Intel Mac, because that's what you currently get for free in GitHub Actions, but because of Rosetta, we can also run this here on this M1 machine. Yeah, I should give this permission, I guess, to run. Let's see. Oh, right.
Is it the quarantine thing?
Yes. So this is something that you also find that you also need to do. Yeah, you need to enter a password real quick. This like when you download artifacts that are not signed and notarized by Apple, you have to remove this quarantine flag. It's an attribute on the file. I could have also removed it from the download file, but I forgot to do this. Oh, no, I'm unplugging.
Breaking things.
Oh, I'm sorry.
All good.
You know me. I like to break things. So finally, third time the charm. Yes.
Yay.
Here's the terminal output. Maybe I should start it again. Yes, so this is the simulation that we built, and if you run the same on JIT, you will find that the ticks per second, it will take some time until it actually reaches peak performance, but here we immediately get 34. This is running through Rosetta and is running with, I don't know, only 2,000 virtual threads, but I hope you get the point, right? You just add the native build tools to your Maven or Gradle project, and then you maybe want to use some of our flags for your application, and then you can compile that to native. You can do all of this for free on GitHub, and actually I forgot how many projects there are, but there's plenty of projects that are using our GitHub Actions. Yeah, I think I need to go back to the GitHub repository and it's something like 1,600 projects, or actually 1,571. So you can just go here and see what other GitHub projects are using the extension. And sometimes there are test repos or demos, but sometimes there's also very big applications that are actually using GraalVM. So for example, Apache Skywalking is apparently now using GraalVM in their build pipeline. Of course, you will find Micronaut and Spring in here as well on other pages. You can get inspired by what other people use this for. I think even like WhatsApp, what's it called? WhatsApp. It's an Erlang GraalVM. No, I forgot what it was called.
Okay, we can trust your word for it.
Yeah. So this one. So a type checker for Erlang, and this one from like the WhatsApp group at Facebook, I guess. They're using GraalVM for making a release. Yeah, here's GraalVM. There you go, right, for testing.
Very cool. Okay, I'm afraid we will be way behind our schedule. We have 51 minutes left.
Okay.
Cool.
So where do we want to go next?
Testing.
You want to do testing?
Yeah, let's talk about it. So let's talk about how you would test such native executables with GraalVM. And the way to do it would be, once again, we encourage you to use our native build tools, so Maven and Gradle plugin. Also, if you're using one of the frameworks that work with GraalVM, this will be included out of the box. So let's look at our native build tools, so the Maven and Gradle plugins. And here we can see testing support, so those will enable you testing your applications in the native image mode as well. And as you can see, this is coming also with the JUnit support, so you can run your JUnit tests, including in the native image mode. And we also get this question, so how often do I need to test my application specifically in the native image mode? And in general, what should be my development kind of experience and strategy like with GraalVM in regards to native? So what we typically recommend here is that you develop your application and test it on the JVM. So you work with it as you normally would with any other Java application. And then you test in the native image mode and then compile to native once in a while, maybe as you're getting closer to production or once a day or in your CI pipeline. But this is not something that you need to do and recompile on every minor change, especially if you are changing things mostly around your business logic and not touching things that can be challenging for native. So if you are changing things about your application logic itself, not touching reflections, serialization, proxies, etc., things should just work. So you should just develop on the JVM and then test on native once in a while. So here is the testing support from native build tools. So if you're doing just basic Java project with native build tools, this is what you get. And then there is testing support coming from frameworks. So if you want to do especially integration testing, one good thing would be to look at what kind of testing support your framework offers. In Quarkus, I believe it's called Quarkus Dev Services, and we have a similar thing in Micronaut called Micronaut Test Resources. So this will be your way to do integration testing with GraalVM and external dependencies coming from the framework, including in the native mode as well. And I mentioned Quarkus and Micronaut, but also Spring Boot, I think, released in the previous release, so the last release version, they also added support for test containers, and that should work in the native image mode as well. So that is how you would do testing. And let's look at how we would test such a native application ourselves. Okay, let me just zoom this out maybe. So what we have here is a Micronaut application, and when we look at it inside, we will see that it's indeed a Micronaut application. So here's my main application class. And this is basically a list of books. So a web application where we can store and then read our books, authors, users, etc. So here's our book repository. And here we are trying to use MySQL. And then we want to make sure that our application works in the native image mode as well. So for that, let us test this application, and I have my little script somewhere because this one is a Gradle project, and as we talked, it doesn't support 21 out of the box yet, so you would need to compile with 17, then compile to native with 21. So instead, we will just use the previous version of GraalVM and run it on the 17 to show you how you can do testing. Yep, let me see where we are. Okay, and let me run this.
So it runs Gradle, the Gradle wrapper with native tests. And as you can see here in our configuration, we're actually using Podman. We just like it a bit more, right, than Docker. Oh, it's already done. Okay,
so it's done. So it wasn't recompiled into native. Normally what will happen with native tests is when you run your test in the native mode, your tests themselves will be compiled as a native executable. So as the end result, you will get your native tests as a, native executable themselves. But this time, since I ran it before and I did not introduce any code changes, it detected this for me and just ran my tests because there were no code changes. But what was happening here is also, since I need my MySQL container to test against this was provided by test containers. And we needed our MySQL container to run. So here we were executing our demo test. Let me just show that one to you. So we are trying to put another book into the repo and then read our existing books from the repo, and that will be MySQL in our case. And that MySQL has been provisioned for us by test resources and test containers underneath. So this is how you would test such native applications.
While you're here, quick shout out to Cedric.
Who wrote this module. He is a very cool guy who wrote this and many other exciting things for the Micronaut. And I believe he should be also here at Devox Summer.
Yes.
So if you want to ask him any Micronaut or Gradle question or just talk to him, he should be somewhere at the conference. Feel free to say hi and tell him that you love Micronaut test resources.
And he is also working on the GraalVM, the Gradle native image build tools. So the native build tools, he is also helping out with that.
Yes.
Yes.
Okay, so we talked about how you will build applications with GraalVM. We talked about testing, and I guess we covered deployments because we showed GitHub actions.
Yeah.
Maybe we just want to briefly mention static images and talk about like Docker deployments. We kind of covered that when you showed that slide, how you can really minimize the container image size with GraalVM. So you build your native executable, and then if you want to really compress it, you can do UPX, and you will get a very small image in the end, if that's something what you're looking for, right? Optimizing the packaging size. One more thing to keep in mind there is that you get multiple kind of deployment options with native image. So you can build a fully static GraalVM native image that will be self-contained and it will include everything it needs to run. So don't have any external dependencies whatsoever. And then with this one, you have a lot of flexibility. You can deploy it in a from scratch container and it will be fully working on its own. And I believe static is something you can do only on Linux for now, right?
Yes.
Yes. And another option will be that you can do what we call mostly static native images, so statically linked against everything except for libc, and then libc will have to be provided by the underlying platform. So those are two options that you can choose from when it comes to compilation and packaging.
Right. So what's up next? Monitoring?
Shall
we do a quick one?
Yep.
Okay. So one thing that I want everyone to know is on the GraalVM website, we not only have docs, but we also recently added this guides tab. And we have a bunch of different guides that you can look at. It's also categorized by the build and debug and configure, so you can go and check that out. What we want to show you is JFR support. So this is a guide that we have developed together with contributors from Red Hat, and tells you how to create your own custom JFR event, but also normal events are also supported. Actually, I should probably go and show you that instead too. See, so if you go into projects, there is the community roadmap where you can find upcoming updates to GraalVM. So we already had the 17 release. Here's the 21 release that came out on 19th. And for the next release, you can already look at the things that we're working on. So for example, enforcing unlock experimental is something that I will take care of. And there's a bunch of things that are planned for the future, one of which is JFR events. Let me try and find it. JFR supported native image. So Robert is working at Red Hat, and he's been driving this a lot. This is actually has turned into a massive list of all the JFR events that are available in the JDK. Some of them are not applicable, because we don't do any class loading, for example. So they don't make any sense, right? But a lot of them are already implemented, and the ones that are missing, we constantly add new ones that are missing. So you can go and take a look at that too. We also do event streaming, experimental support, remote JMX. JMX is something that we have experimental support for, thanks to Robert and the team at Red Hat. And so you can go and check that out on our GitHub. Maybe even contribute and help finishing JFR support. And coming back to the guide, shall I quickly run it?
Yeah, go ahead.
Okay, so if our time allows, maybe we can do this locally on your machine. So I just create a temp directory in here and do it in the temp directory. I can zoom in a little bit. Okay, good. Maybe a bit more. Okay, JFR demo, I think, Java. So what this does is it creates a JFR demo class with a JFR event, description, and label, and then in the main we essentially instantiate this custom event, JFR event. We give this a message, hello world, and then we commit the event, and then we call it a day and exit. Right, so I can Java C this one, and now I can run native image on it. All right, and something that I should do is I should enable monitoring. So by default, we turn this off because we found that our users, they really care about image file size. And of course, like this is adding additional surface in your application, if you will. So we also want to keep from the security aspect, we want to reduce the attack surface as much as we can. But of course, if we want to do monitoring, we might as well enable that. And what we do is we set enable monitoring to JFR. You can also set JMX, client and server. I'm just going to add heap dump because we also want to do a heap dump maybe. And but in theory for this demo we only really need JFR, and that should also be documented in here. So yeah, Java C, enable monitoring, right, and then we can start the application.
So now we can also assess build times on my local machines. It's not as good as our cloud machines. So
yes.
If we were to complain about build times, maybe now would be the time. So let's see.
Well, it's not too bad, and also you get to see the links. So here it takes you to the documentation, right? So if you're in the right terminal, you not only get colors, but you also get direct links to the docs. Okay, so let's see. This compiler
38 seconds on a machine that is, screen sharing and running a lot of other stuff. I would say is good.
Well, and it used only 1.2 gigabytes. It's more or less a hello world, so it's not too bad.
Still, like 30 seconds to compile an app. I remember when it used to be like 2 minutes.
Yeah, it used to be 2 minutes. Yeah. So now we can run the application, and we can use the start flight recording flag that you may know from OpenJDK, and we can set a file name, recording JFR. Okay, we run the application and done. Cool. Another flag that we have is, I think it's called, it's called heap dump heap and exit. So when I use this flag, this is another guide that you can go and look up if you're curious about heap dumps. This creates a heap dump, an hprof file, which you can open in hprof viewers, obviously. And this is a dump of the initial image heap. I told you that native image is more than just AOT compilation. You can also look at the initial heap that is burned into frozen into your executable, which is what we can do here. So now I go and start my visual VM. We're good friends with the maintainers. They're also in Oracle Labs. So now I need to find the I think I did this in like the GraalVM Game of Life. It's in the download directory, right? Yeah, download directory, and then Game of Life macOS. This is where I create. Yeah, I was a bit sloppy.
Excited to get to the building.
Too excited. Yeah. So this is the JFR file. So this one ran on Substrate VM. right?
Which is our little VM included in native
with the
image.
serial GC and compressed references. And I think there's not too much going on here because not enough samples. This application ran really quick.
But also we did not do it now because we want to like cover more things, but you could also run with the JVM stat flag, and then you would have also seen like memory usage real time.
Yes, and here's the Hello World event, right? So this is the custom event that the application creates. And it's showing up in here with Hello World, but there's also other properties, like you can take a look at the initial system properties. So this is indeed running on Substrate VM with Oracle GraalVM compiled on 21, right? And so that's something that you can do. There's lots of other events, and like I said, we're constantly adding more here that you can use. So our goal is to reach feature parity with the OpenJDK, and then you can just use your existing JFR infrastructure if not already, right? And so in the future, you'll be able to just use that as a drop-in replacement, and it will magically just work and continue to work. And the other thing that I did was a heap dump. So there's also a JFR demo H profile. So I can open the heap dump in here, and then we get to see, okay, the initial heap, something like 8 million bytes. And we can explore the heap. So we can look into what's included inside this executable when we started. Of course, cool. That's a coincidence. The first string showing up in here is the Hello World string that will be part of the executable. But you can also see there's some option printing in here. And maybe some error messages in here. So these are string object instances. These are not. This is not code, right? So for example, you can do some cool things with native image. You can shift work from runtime to build time, and then you can create caches, for example, and freeze them into executable. And of course, you can make mistakes, and then this will blow up, and then your executable is something like 500 megabytes, and then you can go and take a heap dump of the initial heap and diagnose a memory leak or whatever you want. So in this application, for example, is over 1,000 hash sets and 1,000 array lists already, even though this is a simple application. So this is stuff coming from initializing the JDK mostly, right?
And we're also getting questions about like agents and additional monitoring options in native image. So there is still more work going on. We hope that we will be able to show more updates to you soon. But also this is something where we expect more kind of engine and library and framework authors to kind of reach out to us and have this collaboration to have more support of it for native image. So hopefully this will come soon.
Shall we do a quick one?
Yes, let's do another like
okay, what do we got?
Fun thing. Oh, this might be my favorite.
Yeah, well, we already had the rabbit. Right, so the prompt here is imagine a Micronaut astronaut and a cute rabbit flying to the GraalVM universe.
So I like how the cute rabbit part turned out. Like Midjourney did really like good a job well.
Yeah.
Should we do one more?
Oh yeah, quick one. Oh wow.
Oh,
that's my favorite. That's my favorite.
So, but maybe you can try and guess what's here though.
Anyone has an idea what's going on here? What's
a lot of small things.
Lots of threads, huh? GraalVM and virtual threads from Java.
Yay.
Like even a prompt like this simple creates amazing art.
Doesn't just say GraalVM, but like threads are more or less covered, I would say. It says some random...
Something, yeah.
Remotely resembling GraalVM, but not exactly.
Yes. Okay, well, let's see.
Okay, let's see. What's next?
Oh, we covered monitoring. More on cool, crazy things.
Yeah,
Shall we do some questions real quick?
Let's maybe do questions before we get into crazy things, and then we will see what exactly we want to show for the crazy stuff.
Okay.
Oh, let's start from the top.
Okay, yeah. So let's try and be quick.
This one we answered though, right? So we can mark this one as
done. Does it work well with tracing agents, or is it tricky to set up?
It's super easy.
Yeah, the native build tools integrate the tracing agent, so you can just run with -d agent equals true and false, and in many cases this should do the trick. You can run your tests, you can run your normal workload, and yes, it should be
super easy. One thing to know, so like if you've been in our presentation yesterday with Josh, if you're running on the framework and then framework generates a lot of additional classes, etc., resources, there can be kind of some noise in the agent output that you would need to look at. But overall, agent is super simple and it helps a lot. We hear this also from our contributors that every time they want to make some library compatible with native image, what they do is they run with the agent and it outputs 90, 95, 100% configuration for you. And it's really very good, super easy to set up, very helpful.
Yeah. Well, the next one really always gets me in trouble with our product management lead, Sean, who's, by the way, also here at the conference. Why is it called native image and not native executable? Well, in our docs, you'll find that we talk about native executables. Sometimes...
But we like calling it native image,
Yeah,
and it's like a
call it-
historical name that we had for a long
Yes.
time. So we are supposed to be saying native executable, but native image is something our community kind of picked up, and we
Yes.
roll with it. So
So one of the problems that GraalVM had is that some people thought about it as a Swiss Army knife that can do a gazillion things, and some people got really excited about the Polyglot or language runtime aspect, and that got confused with native image, and it gets confused with the GraalJIT, and because these things are intertwined sometimes, it can get really confusing. So we are trying to make it easier for everyone to understand this. So at some point we decided maybe calling it GraalVM native image.
Is the technology the component
Yes,
that
the
produces
component.
it?
There's a launcher, which is bin native dash image, and then there are the artifacts called native image. So maybe that's a bit too much. Maybe we should just call them executables. Then we realized, we're also doing shared libraries, so it should be native executables and shared libraries. So that was a bit too much. I think
so the official version is native executables, but if you're asking questions or talking about it, you can call it either images, executables, whatever works for us.
Well, it comes from JLink image, and this is a native image, and I think it's totally fine if you use that term. Many people use GraalVM instead of GraalVM native image, and we're kind of doing that now.
Okay, debugging.
Yeah, debugging is also a fun topic. We have a guide on debugging. There's just one guide, but it's, I think, quite comprehensive, if I remember correctly. Yes, there's a lot of stuff that you can do. So debugging is an interesting topic because
well, this is not your normal Java debugging.
Yes,
right?
because we're in native world. We have to use operating system debuggers, and native image supports GDB debugging. So any IDE that integrates GDB can also be used to debug native images or native executables. And in fact, last week we had a community workshop, and we're collaborating with the folks at JetBrains to bring native image debugging into IntelliJ. And they have already integrated essentially they already had the GDB debugger from C-Line, and they put this into IntelliJ and make it work with native image. So and don't be scared. You will look at Java sources, you will not look at machine code. You can switch to machine code, but you will see Java sources in GDB, which I always think it's mind-blowing that we can do this. And this will give you a real view of the application. So if you're running with PGO and lots of optimizations, you will find yourself jumping through the code because the compiler has optimized so much. Of course, you can turn that off with -0 and debug. You get a better debugging experience. And something that I mentioned there, we have also a research group. Something that we're working on is also JDWP debugging. That's on our roadmap as well. And that will allow you to just use any Java IDE to debug a native image on the Java level without the crazy jumping. And yes, that's something that we're also working on.
But the IntelliJ one, I'm also very excited about it. So they have this for a while, right? They had this experimental plugin that allows you to debug native image, native executables. And they told us that in a month or so, they expanded the support in IntelliJ. So we are looking forward to the next release and the next update, and hopefully it gets easier in IntelliJ.
Here's a similar question about debugging.
Remote.
Yes, you can do this remotely. GDB supports GDB server, and then you can debug a remotely running app the same way. IntelliJ have shown us a demo where they can do debugging on Windows and Darwin, macOS, something that we don't necessarily support on the same level as on Linux. But they do this in containers. So normally you wouldn't deploy on Windows and macOS, you would deploy on Linux, and they have provided they're great in building user experiences, and they've provided an experience where you can build your applications on Windows and macOS, but they're doing this for you in a container without you even noticing, and then you can do normal debugging in the Linux world, right? Which is what you would use in deployment. So you see Java debugging, normal Java debugging, but it's actually happening in a Linux container in the background. Okay, can you also run the benchmark with the instrumented image? Yes, we can.
But
I feel like I already ran it too often already.
Yeah, but also like the results would be like you don't want to run your like production workloads on the instrumented binary, right? You want to use it just like it's technical thing to collect profiles, right? So this is just a temporary thing where you collect profiles and then you use the profiles, but this is not something you should be running on in production. Also, I feel like the performance would be worse.
Oh, you can run it in production to create a profile, but
only for that, right?
Yes,
so
yes,
like
but only for that. You shouldn't use that instead of like a normal image. I feel like maybe the answer should be maybe come by our booth and we run the instrumented image.
Fabio will personally run the benchmark just for you.
Yes, but for time constraints, maybe we should move on. What kind of problems should you be aware of that could occur at runtime after running an application for a while?
I don't think there should be any specific, like either long running or like hitting with a high load should not be issues. Like we asked this question, like are there any like big production deployments of native image that you're aware of? So Alibaba shared with us numbers, but they're running on native image, and you can imagine Alibaba gets a lot of traffic, and they've been doing this for a very long time, not having any issues at all. So there's nothing I can think of that would be problematic. No.
Well, if you're if you're a sane Java developer, you hopefully have good testing in place, and you can run the native test as Alina has shown with our plugins as well.
And like long running, I mean, the only thing I can think about like is heap and GC, but again, you have GC native image, either serial or G1 GC. So like
there's no JIT that can crash, so maybe even stable.
I mean, maybe you can try and see if you can, like hack and kill native image if you try hard enough. But overall, we don't expect any issues.
Yeah. Okay, and what is the relationship between GraalVM native image and Project Crack? Seems like they have some common purposes. The only common purpose, I would say, is startup time, right? And native image can do that, right? We've shown this. But it can also like reduce memory consumption, memory usage, and increase CPU usage, making better use of the hardware that you're allocating to your instances. So and we're more secure. You're not running on hotspot anymore. We have we do the analysis with closed world assumption, and that's something that Crack can't provide in that sense, right?
So for me personally, Project Crack and similar projects in the Java space are a sign that what we are trying to solve with native image is indeed a valid, challenge and something needed in the community, right? So we are targeting startup times of Java applications with native image, and project like Crack validate that indeed there is such need to solve this warm-up and startup challenge for Java applications. Although indeed, as Fabio said, native image solves way more than that, right? So startup is great, it's impressive, but if even in our presentation, what you've seen, what we focus on is really memory usage and the efficiency of your applications and getting you all the things you have on the JVM, so peaks, throughput, etc., but with a much better memory efficiency and startup times. So Crack is great. We welcome more projects like this in the community, but we feel like native image solves way more challenges while maintaining all the benefits of running on the JVM.
Yes.
Okay, if you have more questions, hit us up, and we have 24 minutes left to go. So do we want to transition to the crazy stuff?
Yeah, we can do the crazy stuff. So one of the things that we
we also need to save some time for the exciting announcements that we mentioned.
Yes, for the exciting announcement. So one of the things that we haven't talked about much are our truffle languages. Right, so I want to make this quick. Essentially, what you can do now is instead of using our GU GraalVM updater tool to install a language into the GraalVM JDK, you can now use them as a normal Maven or Gradle dependency. And so that means you can not just run them on GraalVM and use them on GraalVM, but also on other JDKs, of course. And that allows you to benefit from other ecosystems, right? You can use Java, you can extend your Java application with Python code or Ruby code or JavaScript code. So, and all it takes now is just a normal Maven dependency. And that is something that I have prepared already here, I think somewhere. There's an embedding demo. So this is a Micronaut application and the Micronaut application. This is the main, and here's the indexed handler, and it's using our Polyglot API. We call this Polyglot API because you can use this for all the languages we support. And this thing essentially says evaluate a Python script, which we take a quick look in just a bit. Then we from the Python bindings, which is like the main module from Python, we get the generate SVG member. And then on this member we call execute, and we request a proper Java string, which we then return as an image SVG XML, right? And this is inline Python code using text blocks, a new Java feature. This is not necessarily the way we would always recommend doing this, but for the sake of the for this demo, we used text blocks here. You can also put this into a normal Python file and evaluate a file instead of a string. But this thing is a Python method, a Python function, which generates an SVG and then returns that, and we pass that function into here, and then we can call it with execute and turn the Python string into a Java string. And of course, you can compile all of this to native and then run it. So let's see. You can run it on the JIT, but maybe we should just run it on native for now. So this is a Micronaut application, and this started in 27 milliseconds, so very good startup. Hopefully port 8080 is still there. Yes, it is.
So now we are running our app that is a Java app using Python as a native executable,
yes,
right?
as a Python executable, and this is the SVG that we generated, right? This is Micronaut and our GraalPy implementation runtime. We're very excited about this because it will enable using machine learning libraries, for example, from the Python ecosystem in the Java world.
Yep. So 2 things to mention here. So as you can see, that's a native executable. So even if you're using all those dynamic languages such as JavaScript, Python, etc., you can still build a native executable out of your base Java application. Only in that case, we will still dynamically execute that JavaScript, Python, etc. at runtime. But it is possible to compile such a Polyglot application into native executable, as we've seen just now. And in general, Python is something that we focus on quite a bit. So with every GraalVM release, we improve our Python implementation. You can see already many libraries supported on GraalPy. You can run Flask applications easily on GraalVM. And this is something where we invest in quite a bit of time and effort, and this Python implementation gets better every day.
Yes, right. So more cool and crazy things. I'm guessing we are slowly running out of time and should focus on the upcoming stuff. But another demo that we had is a virtual threads demo in Spring. Spring has now proper support for virtual threads, and all it takes is, I think, setting this application property flag. Spring threads virtual enable, and if you do this, every executor that is used by Spring will be replaced by a virtual thread executor, and then you can compile all of this to native, and it will still just work because native image supports virtual threads.
You can still run it. We have almost 20 minutes.
It's fine. I think it's
okay.
This one is just a hello world. One of the things I'm also looking forward to is Oracle GraalVM support for build packs. So right now there's a build pack for GraalVM, which gives you the community edition, but with this new, we haven't really talked much about it.
We have a new free license.
Yeah, we have a new free license. So the GFTC, the Graal free
terms and conditions license.
Yes, allows you to run an Oracle GraalVM, which was formerly called Enterprise, or similar to that, and but you can now use that for free in production, and so we'll also bring that. It's already available through GitHub Actions, You can also install it with SDKman. It's just an SDK install Java 21 Graal.
Yeah, and I guess we skipped that session, but
yes.
our typical recommendation for installation of GraalVM is SDKman. We love SDKman and hope so do you, and that's the easiest way to get and then transition between your JDK installations.
So if you go and download, you can of course like pick a version and a platform and download, but you can also just SDKman install it.
And that applies to both Community Edition and Oracle GraalVM, right? So there is no license acceptance anymore. You can just download it.
Yes, you can just go and download it. And so there will also be a build pack, hopefully very soon. We have a demo here. We're working with the Paketo folks to bring that, and then it will be very easy for Spring users, for example, to use PGO and all those great other security features that we provide, for example, many others in Spring. Okay, so where are we? Coming up? Want to do this?
Yep, let's talk about it.
Yes?
We want to mention two things, right?
Yes, well, one thing that I should, should we do a quick photo? Where did the one go?
The special one.
Yes, the special one.
Okay, so Fabio and I, we are very proud of what we will show to you next. That's like the peak prompt engineering coming from our side. So try to guess what is this. This is our masterpiece. Okay, this is not easy to guess, so we might as well just answer it.
Yes, so the prompt that we used is Josh Long hugging a cute rabbit in spring, black and white stick figures lo-fi.
So if you're considering, maybe we can go back to the picture. If you're considering tweeting one photo from this presentation, please tweet this one so that Josh can see it. We will be very grateful. We are very proud of this one.
Well, yeah, Josh is a big supporter of GraalVM.
And we are very grateful. We appreciate the support.
Yeah, and as such, he also opens interesting issues, I should say. So some of you may have seen Josh speak about GraalVM and native, and one of the things that he complained about was compilation times, and he suggested, could we please play music like while the application is being compiled? So for
you met Josh, he doesn't have that much patience, even if it takes like 40 seconds or 50 seconds, for some people that's way too long. So can we make it better?
Well, I don't get it. He ran, I don't know, 20 builds yesterday, and every build was in around 30 seconds. So build times are improving. But
always can be better.
Yeah, they can always be better, but also us playing music is probably getting us into all kinds of weird trouble. So yes, we responded, and I prototyped like a Josh Long mode that you can use, and then you get music with Josh.
So not music, unfortunately, but maybe this is good enough to as you're waiting.
Yeah. Well, jokes aside, of course, you can just ring your terminal bell once you're get a notification when you're done building, but actually we take feedback like this very serious, right? So like I said,
the reason why we brought this up is because, as we mentioned in the beginning, every time we compile a new application, we need to discover your whole application, so the whole universe that is in that application. And we started thinking maybe that can be changed, right? Because every time as we are compiling your application, we are compiling the JDK classes, all of your dependencies, and every time you're making a minor change in your app, if you were to run the native image build again, it will not build only the delta, but it will have to analyze the whole thing, because we need to have the full understanding of what is happening in your application. So we started thinking maybe that could be improved, and maybe there is a new direction and a new way for native images. Right?
Yes, and this is where our layered native images project is coming in. Again, we're a research group. We are also this is one of our top priorities at the moment. The idea is to allow users to layer images in the same way you can layer Docker containers, for example. So that would mean you can build a Java base image, and then on top of that you can build your application, and we don't need to rebuild Java base all the time. We can lift this, and then we could say, for example, you have a certain set of dependencies, and then you build a base layer image for the set of dependencies that you have in your application, and then you can change your code, and we only recompile what you have changed, right? So as long as you don't upgrade your dependencies, you can you can keep that base layer, and that will make for very short, almost incremental native image builds.
And this
right?
is very cool because you would get two benefits out of this, right?
Yes.
This is quite different from the way you build native images right now. So this will be, challenging. Will probably take us some time, but we are very excited about this project because it will give you two main benefits. A will be quick build times because you will be only recompiling your application code. The rest will stay the same. So you will get very fast, I would say maybe comparable to running your application on the JVM build times. So that's one benefit. And then another one is that if you're deploying multiple instances of the same application, let's say it's a Spring Boot or Micronaut application, maybe they can reuse some of that base dependencies if that's like, 10 instances of Micronaut web server that you need for some reason. So quick build times, but also reusing that base layer. We feel like this could be a great thing for native image in terms of both developer experience, but also deployment model.
Yes. Right.
And should we talk about GraalOS?
Yes. Let me pull out the website.
So as you've seen, we have those cool T-shirts now, and on the back it says, Fabio can demo this. Thank you, Fabio. And what we point to at the back of those T-shirts is this new project that we have, and it's called GraalOS. So this is our big Graal stack website, but we have a new project which is called GraalOS there.
Yes. And GraalOS is essentially, it's built on top of native image or with native image, but it's a no container setup. So instead of using Docker containers, right, we will allow you to deploy applications without an additional container. Now that we have very fast startup with native executables, we find that the next way to push startup is by getting rid of the containers, because you will still need to pull them, you will still need to package them.
So it's never good enough for us, right? Even those small startup times and memory usage of native image, we feel like we still can improve it, and the limitation at the moment could be even coming from this containerized environment. So what if you could deploy native images without containers at all, and have no overhead whatsoever, and just have your native executable running?
Yes, and now you may be wondering, well, containers are great because they provide isolation, and we're going to do this with hardware isolation. So there will still be isolation, but it will not come through normal containers, right? And this will make for very fast and lightweight deployments. So we try to keep your memory, memory will be down, and then costs will be down, and this will be very, very cheap and efficient way to deploy Java applications on the cloud. And of course, this will become available as part of OCI,
Oracle Cloud
Infrastructure, and then you can just go and pick the deployment runtime. And if you pick GraalOS, then you get essentially the same behavior, same peak performance, but a very low hopefully bill, right?
And so I don't know about you, but I'm very excited about the name GraalOS. I think it sounds amazing. So we have GraalVM, we will have GraalOS. So it's all things Graal. I think it's very cool.
Yes. And a part of the stack is also GCN. So you can go and the Graal Cloud Native. So you can go and check out more on our website.
Yes. So we just announced this. There are still things that we are working on, but we think this will be a very exciting new way to deploy Java applications. So stay tuned, and hopefully we will share more updates on this soon. With that, we have exactly 10 minutes left, so maybe we can look at our questions again.
Right. No more questions.
No more questions. Is that
Good.
so? Okay, we can give you maybe 1 more minute to come up with any questions. Also, maybe you want to reflect on the new changes we just announced. And let's see if you have any more questions or comments for now. Let's maybe keep the questions wall on.
Okay.
But also, maybe if you're still thinking about the questions to come up with, we have one more session tomorrow on, I think, 3 p.m. So Thomas Yurenko, our project lead, will have a panel with all the framework representatives where they will talk about the current state and the future of native image. And I think today in the afternoon, also Graham Roche from also our team at Oracle Labs has a Micronaut deep dive. So those are the places where you can learn more. And with that, if there are no more questions, I guess we can thank you for your attention.
Well, one more thing. We are also at the
we have something.
we're also at the GraalVM booth, right?
Yep.
So if you have any questions, something pops up tomorrow in your head, and you want to talk to us, feel free to come by. As Alina mentioned earlier, I care very much about the developer experience. So if you have anything,
complain to Fabio about all your errors and things that can be improved. Fabio is your guy.
Tell me what we should do better, and go and thank Thomas for the amazing work that we're doing here.
In fact, we have a question. That's my favorite one. So what are the downsides to GraalVM, reason to stick with another JDK? Or sometimes people put it like, when should I not use GraalVM? So what would be a bad scenario? My answer is always use GraalVM, but choose a different part of it, right? So with GraalVM, you have options. You have your normal JDK with a new, shiny, highly optimizing, the best ever JIT. So you can run your Java programs as you would on a normal JDK. And in some cases, if you have a longer run application, or maybe you don't want to migrate to native, GraalVM JDK is a great JDK with a great compiler. You're not losing anything at all comparing to your open JDK, wherever is the JDK of your choice. Now with native image, you get additional benefits, such as we showed, startup, memory usage, memory efficiency, security, all kinds of things. So my answer there is always use GraalVM, just choose the right part of it.
Right.
Okay, that is good.
Will you add support for other CI/CD platforms besides GitHub Actions? Yeah, I think there is a ticket on Azure DevOps, which is essentially also using some GitHub Actions infrastructure.
And this reminds me that I also wanted to mention in the monitoring sections that we are working with library framework authors to add more monitoring options, but also we see that cloud vendors add options like custom options on their clouds to monitor native image applications. Specifically, Azure has a number of things to monitor native image applications. So maybe you can raise this with them. They are quite supportive of GraalVM native image on their cloud. So this is something I feel like they could also resolve.
Yeah, we very much appreciate that you like our talk. Don't forget to vote on the DevOps platform too.
Yep.
You know, that would be good too. Yes, well, reach out to us if you have use cases for other CI/CD platforms. We can help look into this. But GraalVM tries to not be weird, right? You can use SDKMN to install it.
It's your normal Java.
Right? It's like your normal Java. So hopefully you can use whatever you're already using for building applications and running applications with Java, and just use GraalVM instead. So, and if you have problems with that,
GraalOS on Kubernetes.
I
feel like that seems unnecessary.
Instead of Kubernetes.
Instead of
you
Kubernetes.
don't need Kubernetes anymore.
So GraalOS is your Kubernetes.
Yeah. Okay. So maybe we should sum up.
Yes.
Right. Okay.
Okay, so hopefully what we covered in those 3 hours is that there are many benefits to GraalVM native image. Many people see GraalVM native image as a solution for fast startup for Java, and it's that, but it's also way more. So with GraalVM native image, you get low resources usage, so you need way less memory, CPU, etc. You can do more with your existing infrastructure, or you can reduce your infrastructure usage but get the same peak throughput and output of your application.
Yes. Yeah. Well, then we are reducing your attack surface. Yes, there is additional work sometimes to be done when you do reflection, but by explicitly allowing what can be reflectively accessed, you're also freezing that set at build time and making sure that your application is not, for example, vulnerable to reflection attacks at runtime and to lots of other attacks, because we don't run a JIT anymore, for example. And of course, native image makes packaging more compact, makes it easier to deploy your applications. And hopefully, you've seen that GraalVM has come a long way in the last couple of years, especially in the last couple of months. We've been aligning with the OpenJDK project, and GraalVM is becoming more and more just a normal GraalVM JDK with additional superpowers. And hopefully today we were able to convince you that,
you should go ahead and use it today.
Yeah, and encourage you to give it a try, right? And feel free to swing by our booth, come and say hello.
If you have more questions or you just want to talk to us, we will be at the Oracle booth. With that, thank you so much for coming. Please rate the session, and we will be happy to talk to you afterwards. Thank you.
Thanks.